Probability is one such topic in JEE mathematics where most of the students, when they attempt 3 questions, will only get 1 question right. Now this problem they encounter because of a very fundamental flaw in their thinking process. They think that probability is primarily based on PNC. Now this generates a problem that every question that they're doing in probability, they're applying the same techniques that they learned in PNC chapter, and that is the reason they will only be able to get 1/3 of the question right, because only 1/3 of the chapter is based on PNC. So if you look into probability, there are 3 very important parts of the chapter. The first is classical probability. Now the problems which are based on classical probability will largely be solved using techniques of PNC only. But if you move towards the second part, that is axiomatic probability, there you need to apply axioms in order to solve problems. So your thinking process should be, out of the 5 axioms that are there with me and one basic premise of Kolmorov, which one of these to apply to get to an answer right. Now if you think in this manner, in this axiomatic problem, then your chances of getting question will be more. Now if you move towards the next part, then there is statistical probability. Here again your mindset should be, you should understand what is the concept of a random variable, how to make a probability distribution table, how to find mean and variance, and then solve questions using only these constructs of statistics. So if you get these 3 parts right, first based on PNC, second based on axioms, and the third based on statistics, then 100% of questions in this chapter can be got right. Now in order to make your life extremely simple, what I have done is, I have divided these 3 areas into 11 problem types. I will give you the systematic theoretical basis thinking process in each of these 11 problem types, give you tangible techniques to handle such problems, and if you watch this video till the end, I can ensure you that you will get your 100% problems based on probability right. So let us start with syllabus comparison. So if you look into this JEE syllabus of 2023 and 2024, you can see there is a major change in the syllabus, and that is Bernoulli's theorem is no more there in the syllabus. So Bernoulli's theorem and binomial distribution is not there in the syllabus. That earlier used to be a very important part. Apart from that, probability of an event, addition and multiplication theorems, Bayes theorem, probability distribution, mean and variance, all of these things are still in syllabus. Now if I start with mind map and go into the actual syllabus of JEE, the actual syllabus of JEE revolves around 3 very important ideas. The first is classical probability, the second is axiomatic probability, and the third is empirical or statistical probability. So these are 3 major heads in this chapter. If you look into the first head, it generally consists of 3 very important types of problems. There are problems which are based on PNC. Now these are the PNC problems only, and I have made a 3-hour video on that. That covers in detail all the kinds of problems that can be asked in PNC, but asked in the garb of probability. So these are the same questions but asked in a little different manner. So the method of solving all this question remains exactly same. The second important type of question is questions based on odds, in favor and against. This is a term that you need to understand what does it mean. And then there are questions based on set theory or Venn diagram. Then if you look into the second part of this chapter, that is axiomatic probability, that is their concept of Kolmorov's basic axiom. So there are 3 or 4 basic axioms of Kolmorov, and that's the way that we do probability. So these are very important. And then there are areas like conditional probability, multiplication theorem, independent events. And then we move towards the idea of total probability and Bayes theorem. And these 5 ideas that we have done here, and plus this one idea of Kolmorov, this sums up the idea of axiomatic probability. Then comes the again a very important part of this chapter, that is statistical probability, and that consists of 2 major parts. The first is the concept of probability distribution and random variable. So we understand what is a random variable, we move towards measuring its probability distribution, and therein we come up with the concept of expectancy or mean and variance. These 2 ideas, and on this he has asked a lot of questions. And then there is this last idea that now is out of the syllabus, that is that of Bernoulli's theorem and binomial probability distribution. Now if I look into the weightage of these chapters in these 3 areas, you can see a lot of questions are usually asked in classical probability, because that are nothing but the questions of PNC only. Second, traditionally axiomatic probability has been a very important area, but recent years statistical probability has become more important. Now let us start with first problem type, and these problem types are those questions that are based in PNC. So as I've already told you, this problem types comes under the classical probability. And if you have to find classical probability, the standard way to do it is nothing but favorable cases
by total number of cases. This formula we are going to use in order to find all of such probabilities. An interesting thing here would be, in order to do so, these favorable cases and total number of cases, both such type of cases in this case will come from nothing but P and C. So this, both the things we are going to find using P and C. And that is the reason, see, I have not tried and covered extensively all the questions based on this idea. The reason is that all such questions are already covered in P&C. So I am only taking those questions that came in 2023 in this specific problem type. So let us start with it. The first kind of problem that was asked in 2023 talks about 3 dice are rolled. Find the probability of getting different numbers on the 3 dice. Now if you already know this question, you can pause this video and try this question. So what we are saying is the 3 dice should reflect 3 different numbers. What is the probability of that? So this first can be done in 6 ways. Second box can be filled in 5 ways. 4 ways. So answer becomes 6 into 5 into 4. And total number of cases. So if I want to find total number of cases, again I will apply my P and C. This box can be filled in 6 ways, 6 ways, 6 ways. So these are favorable cases. These are total number of cases. So if I want to write my probability of the event A would be nothing but 6 into 5 into 4 divided by 6 into 6 into 6, and this 6 will get cancelled out. This 4, again this will become 3. So what we are getting is nothing but 5 by 9. What they're saying is this is equal to P by Q. So here P is nothing but 5 and Q is nothing but 9. So Q minus P will be equal to nothing but 9 minus 5, that is nothing but 4. So you can see that the option B comes out to be true. So what we have done again is we have figured out those favorable cases and total number of cases using P and C. Now this is a problem based on again P and C. In this problem what we are going to do is, if we have an hexagon, the question says that if I choose any 3 vertices of this hexagon, we should get an equilateral triangle. See, now this can happen only in 2 cases. If I choose this part, this kind of a situation, or another equilateral triangle that is possible is if I choose these. So there are 2 cases, favorable cases, and total number of cases would be 6C3. These are the total number of ways in which we can make a triangle. So if I simplify this, this is 2 by 6 into 5 into 4 by 3 into 2. This will get cancelled out and the answer comes out to be 1 by 10. That is nothing but option A. This question talks about an unbiased die on which on the faces there is -1, -2, 0, 1, 2, 3. These 6 things are written on its faces. 6 numbers are there. What they're asking is, if I throw this same dice 5 times, and if I do so, any one of these 6 numbers will appear. The product of the outcomes of these 5 throws needs to be positive. So see, this can only happen in these 3 cases. The first case would be when all of them are positive. So all the 5 throws give me 5 positive numbers. This is one scenario. So now how many ways can this happen is, let us say that these are the 5 boxes that I need to fill. So this 5 box can either have 1, 2 or 3 because there are only 3 positive numbers. The next can also be filled in 3, again 3, then again 3, then again 3. If I talk about total number of cases, every box can be filled in 6 ways. So favorable cases are 3 raised to the power 5, total cases are 6 raised to the power 5. If I go towards case 2, now let us see what case 2 says. Case 2 says that what I can also have is 3 positive and 2 negative number. In this way, the 2 negatives will multiply and generate a positive number. So this is also possible. So again, what we can do is, out of these 5 boxes, I can choose any 2 box in 5C 2 ways. Fill negative numbers in this. Let us say these 2 boxes are there, we need to fill negative numbers. So now this can be filled using -2 and -1. So there are only 2 choices to fill both of these boxes. And then whatever is remaining can be filled in 3, 3 and 3. So these are favorable cases. If I divide this by total number of cases, that is 6 raised to the power 5, I should get my answer. And there could be a third case, and now you might have guessed that case as well. What we can have is 1 positive and 4 negative. This is also possible. Now in this case, what we can do is, out of 5 boxes, I can select 1 box. In those 1 box, I can place 1 positive number in 3 ways. And the remaining 4 boxes can be negative, can be filled in 2 ways. These are my favorable cases. If I divide this by total number of cases, which in this case would be nothing but again 6 raised to the power 5. So what I've got is case 1, case 2, case 3. In order to get my final probability of this event A, my answer would be nothing but sum of these individual probabilities. So 3 raised to the power 5 by 6 raised to the power 5. 5c2 into 2 square into 3 cube by 6 raised to the power 5. And the last part, that is nothing but 5c1 into 3 into 2 raised to the power 4 by 6 raised to the power 5. If I add this up, it comes out to be 521 by 2592. That is nothing but option B. So quite a simple question based on method of cases. Now this next question can again be solved using method of cases. So if you look into this case, what they're saying is the sum of the numbers that appeared on two fair dices. If I add these two numbers that are coming on two fair dices, then that number is equal to n, and then n should be in such a manner that these three numbers are in geometric progression. Then for such event, the probability comes out to be k by 48. Find the value of k. This is what we need to do. So for doing this, what we are going to do is basically first check out what can be the possible values of n. So let us say that the first dice 1 is coming, the second dice also 1 is coming. So we are taking how many different cases can be there. And if I have a very systematic way of forming the cases like I am doing, it is very simple to do. So the numbers that we are getting is 2, 3, 4, 5, 6, 7. Now let us change, and this technique I also taught you in P&C. Let us start with 2 to 2 plus 2, 2 plus 3, 2 plus 4, 2 plus 5, 2 plus 6. And now again the sum comes out to be nothing but 4, 5, 6, 7, 8. And then 3 plus 3, 3 plus 4, 3 plus 5, 3 plus 6. So again what you are getting is 6, 7, 8 and 9. And then we can move towards 4 plus 4, 4 plus 5, 4 plus 6. This comes out to be nothing but 8, 9 and 10. Finally, towards nothing but 5 plus 5 and 5 plus 6. That comes out to be 10 and 11. And ultimately only one case is remaining, 6 plus 6, 12. So we can see from our observation that the possible values of n can be from 2, 3, 4 up till nothing but 12. So let us write these values and check which of these, if I satisfy in the relation that is given to me, 5, 6, 7, 8, 9, 10, 11, 12. If I put this value in n minus 2, root of 3n and n plus 2 should be in GP. So if I put 2, what am I getting? So the first number, if I put 2, n equal to 2 comes out to be 0. So once I am getting 0, there is no possibility of any kind of GP. So this cannot be my answer. So obviously this is out of the picture. If I take 3, then 3 minus 2 is 1. That is fine. But then 3 root 3 will become again 3. And then 3 plus 2 is 5. So first, now again this is not in GP. So not a correct answer. Let us take 4. So if I take 4, then 4 minus 2 is 2. This will become root 12. And then 4 plus 2 is 6. And now let us divide and try. So if I divide the first two terms, it comes out to be root 3. And if I divide the second two terms, it is nothing but 6 by root 12. So if I take this root 6 in the bracket, this becomes 6 into 6 by 12. And here you can see that this is coming out to be in GP. So this is a valid value 4. It can be accepted. Now you can see that 4 is coming in this one case. 4 will also come in this one more case. We need to also keep a track of these things. Now if I move further, let us also check for 5. So if I take 5, 5 minus 2 is 3. This becomes root 15. And then 5 plus 2 is 7. So this is not in GP. So again, not important. 6 if I take, then 6 minus 2 is nothing but 4. And then root of 18. And then nothing but 8. Again, this is not. So in this manner, we can keep on counting, and you will realize that in none of these cases, there will be a GP. So only one possible scenario is there when the sum becomes 5. And you can see that this can happen in 3 different cases. When on the first dice we get 1, in the second 3. The first we can get 3, in the second 1. And one more case is basically on both the cases we get 2 and 2. So there are these 3 cases. So out of total 36 cases that are there, these are the possible cases. So our answer becomes nothing but k by 48. If I divide, this comes out to be 12 into 3, 12 into 4. 3 will get cancelled out and the value of k comes out to be 4. That is nothing but option D. Now this very beautiful question came in 2023. In this question, what they are talking about is maximum value of product of two positive integers when their sum is 66. Now whenever somebody says two positive integers, what does that mean in mathematics is am is greater than equal to gm. So first we'll have to apply am is greater than equal to gm. This is first part, and then solve this inequality to find the possible values of x. And then in the third part, we have to apply P and C to get the probability. So your fourth step is going to be finding probability. So these are the 4 steps that we are going to do in solving this question. Now let us start with the first step. That is nothing but applying am is greater than equal to gm. So what they are saying is if we have taken two numbers, their product, so let us say that those two numbers are nothing but x1, x2. So what we are saying is if x1 and x2 are those numbers, both of them are greater than 0. So what I can write is x1 plus x2 will always be greater than equal to root of x1, x2. Am is greater than equal to gm. Once we have done this x1 plus x2 they have given us 66. So this becomes 66 by 2 is greater than equal to root of x1, x2. Once I do that, what I have got is x1, x2 is always smaller than equal to 33 square, and this is nothing but m. So m is smaller than equal to 33 square, and what I want is maximum value. So m is nothing but the maximum value. So instead of writing smaller than equal to, let us put equal to. We have got the value of m by applying am is greater than equal to gm. Now let us come on to the next part. In the next part we have to solve an inequality. Now in this what they are saying is x into 66 minus x is greater than equal to 5 by 9 into m. M is nothing but 33 square. And if I simplify this, what you can get is x into 66 minus x is greater than equal to 5 into 11 into 11. And now if you take them on the same side, this becomes x square minus 66x plus, and this I can write as 55 into 11 is smaller than equal to 0. Why are we doing that? Because now we can split the middle term. So if I split the middle term, this can be written as x minus 55 into x minus 11 is smaller than equal to 0. So from here we have got the range of x that lies between nothing but 11 and 55. Now let us come on to the third part, that is the P and C part. Now what they're saying in the third part is we need to find such values of a for that x is a multiple of 3. So how to calculate the number of multiples of 3? So the method is very simple. Take this 55, divide by 3, and then take this 11, divide by 3, put a greatest integer function. So from that we can get all the numbers divisible by 3 between 55 and 11. Once we do that, this comes out to be nothing but 18, and this comes out to be nothing but 3. So this difference comes out to be 15. Now in the fourth part, if I want to find the probability, my favorable cases are 15. My total number of cases would be nothing but from 11 to 55. So how to find that? So 55 minus 11 plus 1. These are the total cases. I have applied the formula of nth term of an arithmetic progression. So once you do that, what we are getting from here is nothing but 45. So the answer comes out to be 1 by 3. And if I check my options, my A option comes out to be true. If I look into this next question of 2023, it is a question based on matrices determinant. Such kind of questions we again saw when I covered the PNC part. Now again we are looking into same kind of question, and I told you there that these kind of questions are based on making cases. So let us see what are the possible cases they are talking about. The first thing that we can understand is this matrix is nothing but a 2 cross 2 matrix. So if I write all the terms, so what I will get is A12, A11, A12. and then A21, A22. So these are the 4 terms. Now what they're saying is each of these terms can take value 0, 1, 2. Now these are the possible values that these terms can take. So now if I find total cases, how many total such matrices might be possible? So the first can be done in 3 ways, second can be done in 3 ways, fourth 3 way, and third 3 way, and fourth 3 way. So 3 raised to the power 4. Total cases are nothing but 81. This is the first part. Now in the second part, if I move further, what they are asking is basically such matrices or the probability that the matrix is invertible. So it is better to find those matrices which are non-invertible. So the important thing about non-invertible matrices, they are singular in nature. So what does that mean is if I subtract those cases when the probability that the determinant of matrix that is given to us A, this becomes nothing but 0. If this happens, then we have got our answer. This is simpler to do. So this is what I need to find. So I need to find those cases when the determinant will become 0. So this becomes a third part of the question, and then make a table. So if I write the determinant, it is going to be nothing but A11 into A22 minus A12 into A21. Okay. So now if I saying that this is equal to 0, that would mean A11, A22 is equal to A12 into A21. These needs to be equal. So if this is equal, what we are going to do here is basically, let us make cases. If I make a small table, A11, A22 and A12, A21. So what we need to do is, if I'm selecting two numbers on the left hand side, their multiplication needs to be that on the right hand side. So now let us see how many such cases are possible. So see, 0 is going to play a very important role because all the values that I can assign needs to come from these 3 elements only, 0, 1, 2. So now let us play this game. So now first case that I can say is all the 4 become 0. So all the 4 can become 0. This can happen only in one case. Then what we can have is at least 3 becomes 0. Not at least, exactly 3 becomes 0. So now what you can do is either you can make this to 0 or that to 0. So corresponding to that, there will be 2 cases. Let us say that we have taken these to 0. Now the 0 can come here or here. So again, you have 2 cases corresponding to that. Let us say that out of these cases, I have put 0 here. So now this element that is here, this can again be filled using 1 or 2. So again, there are 2 cases corresponding to that. The first 2 cases came because we could have chosen 0, 0 in the first part or the second part. Second 2 cases came because in the second part, I can take 0 as first element or second element. And the third, now this blank can be filled using 1 and 2. So again, 2 cases. Now what we can have is 2 zeros. So now if I take this 0, so again either I can put 0 in this position. So corresponding to this, there can be 2 cases. So I'm moving towards 2, 0 now. Let us say that I have put in here. So now this place can again be filled using 1 or 2. So there are 2 cases. Out of this, again, I have a choice. I can put 0 here or here. Let us say if I put it here. So again, I had 2 choices. And this box, now I can fill using 1 or 2. So again, 2 choices. So we have got again 16 choices here. And if I move further, then what I can have is I think about a case when there is no 0. So I can have all the 4 elements equal like this. 1, 1, 1, 1. Or I can have 2, 2, 2, 2. In both of these cases, again it will be 0. And or I can take is basically 1, 2. Or 1, 2. So again, you can see that first one can be arranged in 2 different ways. Second one can be arranged 2 different ways. So there are 4 cases. So if I add all of these cases, let us see what I'm getting. So if I add all of these cases, what am I getting is nothing but 1, 8, 16, 1, 1 and 4. So if I add this, it becomes 6. 6 plus 16 becomes nothing but 22. 22 plus 8 becomes 30 and this becomes nothing but 31. So now if I apply formula here, what I'm getting is 1 minus favorable cases. This is nothing but 31. Total number of cases was nothing but 81. And if I simplify this, what we are getting is 50 by 81. And that is nothing but option C. Now this next question is again based on matrices and determinants. In this next question, what they're saying is n is a value that comes when a fair die is rolled. So the possible values of n can be nothing but 1, 2, 3, 4, 5, 6. Now what they're saying is this system of equation will have unique solution. Unique solution will come when delta is not equal to 0. So in case of this, the delta is nothing but 1, 1, 1. The coefficients of x, y, z in all the 3 equations. So this should not be equal to 0. So if I solve this or open it along the first row, it comes out to be 1 into n square minus 6. Second becomes 2n minus 6. And the third becomes 1 into 6 minus 3n. And this should not be equal to 0. And this becomes n square minus 6 minus 2n plus 6 plus 6 minus 3n is not equal to 0. This 6 will get cancelled out, and what we have is n square minus 5n plus 6 is not equal to 0, and that means n cannot take two values, that is 2 and 3. So unique solution will come when n can take other values, that is 1, 4, 5 and 6. These four values are fine. So corresponding to that, probability becomes 4 by 6. And if I compare this by k by 6, then you can see the value of k comes out to be nothing but 4. So this is what we are getting. So what they are asking is basically, if I take this value of k and if I add all the possible values that are of n that are possible, so 1 plus 4 plus 5 plus 6, what is this value? So this comes out to be 20, and that is nothing but option C. So in this 2023 question, what we are looking into is basically a team picking their t-shirts. So what is happening is there are 15 team members picking up their t-shirts with their name written on the back. And what they are asking is probability that at least 3 players pick the correct t-shirt. So 3 can be correct, 4 can be correct, till 15 can be correct. That is what they are asking. So a good or a logical way to answer this question is, let us subtract from 1 the probability when exactly 2 are correct and 13 are incorrect, minus probability that 1 is correct and 14 is incorrect, and then probability that 0 is correct. So if I do that, I will be easily able to get my answer, because if I do other cases, they are much more than this and the calculation becomes even more complicated. Now here, if I want to do this, for the first probability, out of this 15 people, I can choose any two, give them the right t-shirt in one way, and the remaining 13 should go into wrong ways. So the way is nothing but D13. D13 is nothing but D arrangement. So what we are doing is we are using here the formula of D arrangement to get to an answer, and the dn formula was nothing but n factorial into 1 minus 1 by 1 factorial, and it will go till minus 1 raised to the power n by n factorial. This was a formula of D arrangement of n objects. This is what we are using, and total number of cases are nothing but 15 factorial minus 15 c1 into d14 by 15 factorial, and then d15 by 15 factorial. See, now this is simple to do, anybody can do this, but the problem is how will you calculate this and come to the answer, because even if I find d13, this is huge number. And here comes an approximation that you can use in this question, and which is the tricky part of this question. So the approximation is, if you are writing d13, what you are actually writing is d13 into 1 minus 1 factorial plus 1 by 2 factorial, and this will go till minus 1 raised to the power 13 by 13 factorial. So you can see that after a certain point of time, the contribution that is happening is really low. So I can approximate this series with E. Now what is E? If you write the expansion of E, it is 1, sorry, e raised to the power minus 1. So e raised to the power expansion is 1 plus x by 1 factorial plus x square by 2 factorial. And like this, it is an infinite series. So if you are replacing x by minus 1, it becomes 1 minus 1 by 1 factorial plus 1 by 2 factorial. So you can see you are getting the same kind of series as we have been given here. So what I can do is I can replace this. So if I replace this, this can be approximately written as 13 factorial into 1 by e. And this is one of the approximation that will make your calculation easier, because now if you use this logic, your answer becomes 1 minus 15 C2 is 15 into 14 divided by 2 into 13 factorial by 15 factorial into 1 by e. Then if I want to write the next part, I can write it very simply as nothing but minus 15 by 15 factorial into 14 factorial by e, and the last part can be written as nothing but 15 factorial by 15 factorial into 1 by e. Now e value you know, and if you simplify this part, it comes out to be nothing but 0.08. So this is the trick in this question, that how will you calculate it, because D arrangement we can all apply and get to an answer. But then dearrangement here, if you do actual calculation, is very long. So this approximation of dearrangement as nothing but n factorial into 1 by e. Because the numbers that are given you, there it is possible to do this. We'll get you to the answer very fast. If I move to this next question, we earlier did a question that talked about sum of numbers obtained when two dices are thrown. And then we noted that the minimum is when 1 plus 1 will happen, and maximum would be when 6 plus 6 will happen, and all the intermediate numbers are covered. So we are looking into number 2, 3, 4 up till 12. So these are the possible values of n that are possible. We did this in that question. So again, that question is getting repeated conceptually. What they're saying is, what is the probability that this inequality is satisfied? Now let us take few values and see what is happening. So if I put 2 here, it becomes 2 square. And 2 square is equal smaller than 2 factorial. This is not getting satisfied because left hand side is 4, the right hand side is 2. If I write 2 cube, it is 8. This is smaller than 3 factorial, again not getting satisfied. But if I start from 4, you can see it is 16. And 4 factorial will become 24, and this is getting satisfied from this point onwards. So what you can see is there are only two cases when it will not get satisfied. When the sum of the two digit is equal to 2, so this is one such case. And when the sum is equal to 3, so 3 will happen when 1 2 happens or 2 1 happens. So you can see that out of 36 cases that are possible, there are 3 cases in which this condition will get violated, otherwise it is fine. So what is the probability? So if I try and find the probability of this event, it is nothing but those 33 favorable cases by 36 cases. And this comes out to be nothing but 11 by 12. This is given as m by n. And what they are asking is the value of 3m, 4m minus 3n. And if I put the value, this comes out to be 4 into 11 minus 3 into 12. So this is 44 minus 36 comes out to be 8. And that is nothing but option C. Now let us move towards next problem type, that is nothing but set theory based problems. Now in all such problems, we know that this is again based on our classical probability only. But in order to solve questions, we are using Venn diagram, that is one. Sometimes we'll use Venn diagram. Sometimes we'll use this relation of number of elements in A union B. That is nothing but n of A plus n of B minus n of A intersection B. So primarily we are using this formula and Venn diagram to get to an answer. Now let us see what kind of questions JEE has asked on this concept. Now this first question is an extremely simple question that was asked in 2010. All you need to do is draw a Venn diagram. So if I draw a Venn diagram, the answer would be self-visible. What they are saying, there are two sets A and B. And if I draw a Venn diagram, this is how it is. So this is my set A. And this is my set B. So what they're saying is the probability that exactly one of them occurs. So exactly one of them will occur in this case. So this is when exactly A happens and this is when exactly B happens. They are saying that this probability is 2 by 5. Now what they're saying is A or B occur. So A or B would mean we are talking about this region that is there in only A, in only B. And this portion that is A intersection B. So now what they're asking is, if I know both of these things, what they're asking is basically what is the probability when both of them occur. See, so what they are asking is this region. So what we are saying is, if I take my earlier probability that is 2 by 5, add this new probability that is x, it should be equal to the total probability of the union, and that is given as 1 by 2. So x becomes nothing but 1 by 2 minus 2 by 5. That comes out to be 1 by 10. Option A. So very simple problem if you use Venn diagram. You can directly apply the formula of A union B union C. Now this is given as nothing but alpha, and this can be written as P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. This is the formula. Now this is equal to nothing but alpha. Now let us simplify. P of A we already know can be written as nothing but 0.6. P of B is nothing but 0.4 and P of C is nothing but 0.5. Now what we do not know is in value of P of A intersection B, because A union B is given. But from this union you can write the union as P of A plus P of B minus P of A intersection B. And this is equal to nothing but 0.8. From here we know these two values, that is nothing but 0.6 plus 0.4. So from here it is possible to find the value of P of A intersection B. And P of A intersection B comes out to be nothing but 0.2. Once we have done this calculation, I can put 0.2 here. And let us delete this part because future it will not be required. B intersection C they have already given in the question as nothing but beta. Let us put this value. And C intersection A already given as 0.3. These are the values that we have already got. And then the last part, A intersection B intersection C, they have also given this value as nothing but 0.2. This is nothing but equal to alpha. And if I simplify this, what we are getting from here is nothing but 1.5. This 0.2 and 0.2 will get cancelled out. Minus beta minus 0.3 is equal to alpha. So 1.2 minus beta will be equal to alpha. Now the range of alpha is given. Alpha lies between 0.85 to nothing but 0.95. So if I do just one more step here, I should get my answer. From here, beta can be written as 1.2 minus alpha. So see, the minimum value will come. The minimum value will come when we subtract the maximum value of alpha. So the minimum value of beta is nothing but when I supply 0.95 and that becomes 0.25. And the maximum value will come when I take the minimum value of alpha, that is 0.85. So it becomes 0.35. Now along with this, see, it is highly recommendable that we should also check. So this was first condition. Check the condition for probability of B intersection C. So this probability needs to be greater than or equal to 0 in this case. And the maximum value can happen when B, the smaller of set B and C is a subset. So this value, this is the smaller one. So this becomes 0.4. So this is the value where it can lie. But this is well under whatever is given to us. So this becomes our answer. So A option is correct. Look into this next question that came in 2023. This question talks about a sample space having elements W1, W2, W3 till Wn. And what they're saying, how they're related, their probabilities related is with this formula. So what I can put is here, the minimum value I can put is 2. So this becomes P of W1 by 2. And then if I put P of W3, it becomes nothing but P of W2 by 2 again. So in terms of P of W1, if I write it, it becomes by 2 square. So if I take this P of W1 as K, it becomes K by 2 and this becomes K by 2 square, and it will keep on happening. Now there are infinite elements in this sample space. So what I can do is, if I say that the probability of all those elements, if I write till n, and there here n is infinity, so till infinity if I write it, it should be equal to 1. So this is nothing but K. The next becomes K by 2, then K by 2 square, so on and so forth till infinity is equal to 1. This can be written as A upon 1 minus R is equal to 1. So from here you can see that the value of K comes out to be 1 by 2. So this is what we are getting. Now let us come back to the third part, that is the question part. Now what they're saying is, what are the values of A that are possible? So if I write all the possible values of n, so very good way to write would be, first let us take the value of L as 1. So if I consider value of L as 1, and I will also tell you why am I doing it. So it becomes 2K plus 3. And if I take L as 2, it becomes 2K plus 6. Another thing that I can do is I can take the value of K as nothing but 1 now. And after that, all natural numbers are possible. So this becomes nothing but 3L plus 2. And if I take this as again K is equal to 2, it becomes 3L plus 4. And then if I take K is equal to 3, it becomes 3L plus 6. See, why am I doing that? There is a reason behind that. The reason is that, see, if you take, and this is Euler's division lemma that you learned in class 10, that if I'm dividing any number by 2, the remainder can be either 0 or 1. So when we are writing 3 here, what that mean is basically, if I take 2 from this 3 from the first part, the remainder will be 1. So all the numbers that are odd we are covering by writing 2k plus 3. Not all. There will be some initial numbers that will be missing out. So if I take or consider and write all such numbers, if I put k equal to 1 here, all such numbers will start with 5, then 7, then 9, then 11, so on and so forth. If I write all of these type, it would be nothing but if I start putting k as 1, this becomes 8. Then keep adding 2, you will get the next number 12, 14, so on and so forth. And then if I start writing the third type, now again, when we are dividing something by 3, the remainder can be either 0, 1 or 2. So see, two remainder numbers are getting covered here. This is equivalent to 1 remainder and this is equivalent to 0 remainder. You can see that in the long run all the numbers will get covered. Only we need to worry about this initial numbers what we are missing out. So let us write and see what exactly are getting covered here, and then we will write what exactly is missing, and from there we will get the probability. So let us write these numbers. So if I put L equal to 1 here, what am I getting is nothing but 5. And then you can keep on adding 3. This becomes 8, then 11, then 14, so on and so forth. From here also, if I start putting L is equal to 1, this becomes 7. Then you keep on adding 3, 13, so on and so forth. And then if you put L is equal to again nothing but 1, this becomes 9. Then keep on adding 3, you will get the remaining numbers. So if I write out the missing numbers, 1 is missing, then 2 is missing, then 3 is missing, 4 is also not there. And after that 5 is there, but 6 is not there. So these are the missing numbers from all the natural numbers that are out there. And rest of the numbers, if you see, are covered in this series somehow. So what we need to do is, if we want to find the probability, what are the numbers that we are missing out of the total numbers? So I will subtract probability of those numbers. So W1 is missing, then P of W2 will be missing, P of W3 would be missing, then P of W4 would be missing out. So if I write this down, and then P of W6, of course. Now this is nothing but K, this is nothing but K by 2, this is nothing but K by 2 square, this is nothing but K by 2 cube, and this is nothing but K by 2 raised to the power 5. And if I write it down, this is 1 by 2, minus 1 by 4, minus 1 by 8, minus 1 by 16, minus 1 by 64. And if you simplify this, this comes out to be nothing but 3 by 64. And this is nothing but option D. So again, let us go back and understand what happened. In this question, there were 3 parts. In the first part, what we are doing is, we are finding the value of W1, because all the probabilities are in geometric progression. So we have written an infinite GP, and since the sum of probabilities of all the elements in the set needs to be equal to 1, we add it up and it came out to be 1. From there we got the value of K. Once you have got the value of K, now we are coming back to the question and writing all the possible values that Wn can take based on this condition that n should come from 2k plus 3l, where k, l and l are natural numbers. So we saw that all the numbers are possible except 1, 2, 3, 4 and 6. So out of total probability, that is 1, we subtracted probability of these numbers and got the answer as 3 by 64. Now this 2022 question is a very simple question but written in a very difficult expression. So what does that mean is, the question says that if I want to find the probability of any event E, it will be corresponding to n by 36. So what does that mean is, if I want to find P of E of 1, it is 1 by 36. P of E2 is nothing but 2 by 36. Similarly, if I keep on writing, then till P8, if I write, it will be nothing but 8 by 36, and if I add all of them, it comes out to be 1. Now what is the question? So this is the context of the question. Now what is the question? That is the difficult part. Now say they are saying is number of such sets such that A is a subset of S. So out of this, how many I can take in such a manner that if I add all of those events, the probability should be greater than or equal to 4 by 5. Okay. So what does that mean is, now let us say that if I take all of them, so 1 by 36, 2 by 36, till 6 by 36, till 8 by 36. And if I add all of them, so obviously if I take all of them, it will be greater than 4 by 5. But even if I skip this 1 and write 2 plus 3 plus 4 till 8 by 36, still is going to be greater than 4 by 5. So what are they saying is, how many such possible combinations of set A are possible in such a manner that if I skip few elements also, the sum of the probability should be greater than or equal to 4 by 5. This is what the question is saying. So in the third part, once I've understood the question, what should happen is, when we are taking this 1 to 8 element, the sum, whatever we are writing, let us say that sum is A. So this a by 36 needs to be greater than or equal to 4 by 5. And if I simplify this comes out to be 4 into 36 by 5. And if you simplify this comes out to be a needs to be greater than or equal to 29. Approximately. So give and take, because all the numbers that we are considering are here natural numbers. So how many such cases are possible? That if I take sum from 1 to 8, the sum should be greater than or equal to 29. So see, now let us write those possible cases. To one possible case is when we take all. If I take all, corresponding to that there is one case. Now next what I am doing is I am taking 7 out of them. So if I take 7, then how many cases are possible? So now if the total sum is nothing but 36. So out of these 36, if I skip 1, still it is fine. I can also skip 2, still it is fine. 3 is also fine. 4 is also fine. 5 is also fine. 6 is also fine. 7. See, if I replace 7, you can see that it will become nothing but 29. So corresponding to this, there are 7 cases. So 7 is a possible value. Another thing that we can do is what will happen if I take 6 out of them. So now whatever 2 that we are removing, after that the sum needs to be greater than or equal to 36. How many such cases would be possible now? So see, now what I need to do is basically what can I escape out of these 8 values that we need to see. So 36 is fine. The sum of the 2 digits that we are considering, actually it should be greater than 20, that should be greater than or equal to 36 minus 29, that is nothing but 7. So if I take 2, the sum of them should be smaller than or equal to 7. This we need to do, this we need to consider. So if I do that, if I take these 2, it is also fine. So corresponding to 1, how many cases are there, we need to understand. So if I take 1, corresponding to 1, I can also take 2. Corresponding to 1, I can take 3. Corresponding to 1, I can take 4. Because the sum can go up till 7. Corresponding to 1, I can take 5. Then till 6 I can go. Now if I start with 2, corresponding to 2, I can start with again 3. It is fine. 2, 4 is also fine. And 2, 5 till here I can go. And then corresponding to 3, 3 is fine. Till 3, 4 I can go. Corresponding to 4, 4, 5. This is not possible. So this is the limit. This is what till where I can go. So you can see that how many cases are there. 5 plus 3, 8. 5 in the first part, 3 in the second part, and then 2. So again 10 cases are possible. Now if I consider, so this what we have done is done till if we have taken 6 elements. Now let us take 5 elements. So if I take 5 elements, what should happen is basically the sum of the 3 elements should be smaller than or equal to 7. So you can see that if I remove these 3, this is the only possible case. So corresponding to this, only one case would be there. And if I add all of them, now what I'm getting is 90. That is nothing but answer to this question. So the complexity of this question does not come from the last part, that is the counting part. The complexity of this question comes from understanding what the question is trying to say, and that is the difficult part. What they mean is basically how many such combinations are there such that the sum of the numerator is greater than or equal to 29. Now the third kind of problem that we are going to discuss is problems based on geometrical probability. Now in such kind of problems, there are 3 important things that you need to note. The first thing is problems which are based on one dimension. So in this problem, what will happen is we will be given a length. Let us say that the total amount of length that can happen is 0 to 2 in the sample space, and what we can ultimately get out of this as a part of favorable cases, let us say 0 to 1. So in that case, the answer will become the length of this part, that is 1, divided by the length of total, that is 2. So in one dimensional, the concept is length of favorable divided by length of total. This is the formula that we are going to use. Another case in the same scenario is nothing but the one based on 2D. So if the question talks about 2D scenarios, in this case, we are going to discuss areas. So what we are going to do is we are going to write favorable area by total area. And in the third part, a third discussion, we can have a 3D diagram also where we can talk about volumes. In such questions, we can talk about favorable volume by total volume. You could have understood the whole discussion. In this case, what we need to case in 1D length by length, in case of 2D area, favorable area by total area, and in case of 3D, favorable volume by total volume. Now let us see what kind of questions JEE has based on this idea. If I look into this question that came in 2023, in this question, what the question says is, if I take two real numbers between 0 and 60, so let us say that both of those numbers are x and y. So what we have is x should also lie between 0 and 60 and y should also lie between 0 and 60. So if I plot them on a graph, what I'm going to get is a sample space. So this y is equal to 60, this is y is equal to 0, this line is x equal to 60, this is x equal to 0. So what we are talking about is this region that lies between it. So this is our sample space. So if I find the area of sample space, the area comes out to be nothing but 60 into 60. Now let us move on to the second part of the question. The question says that this is done in such a manner that if I take the absolute difference lies smaller than a. So if I write the value of x minus a from here, it is going to lie between minus a and a. If I plot this out, what am I going to get is, this was my original sample space. Now I'm talking about a line. This line is going to cut like this, and this line is going to cut like this. So this line is nothing but x minus y is equal to a, and this line is nothing but x minus y is equal to minus a. We need to stay between these lines. So what we are talking about is, this is our favorable case between this. So if I want to find the area of this region, that will become my third part. You can see that this would be nothing but a, this is nothing but 60. If I find the area of this small part that is available with me, this and this part will have the similar kind of area based on symmetry, and subtract it from the total, I should get my required area. So the total area is nothing but 3600 minus half of 60 minus a into 60 minus a. Now this is happening 2 times, so into 2 will also put. So this is nothing but my favorable area. Now what they are saying in the fourth part of this question is, if I find the probability of this event, it is nothing but 11 by 36. So if I put it here, favorable area is nothing but 3600 minus 60 minus a whole square by total area, that is 3600. This is nothing but 11 by 36. If you solve this, the value of a from here comes out to be 10. Now again in this 2023 question, they are talking about a point x comma y that lies in a region bounded by y-axis and these two lines. So if I plot it down, this is how it is going to look like. My first line I can plot like this, and in this line what you can see is, if you put y is equal to 0, x becomes 6, so this point is nothing but 6 comma 0, and if I put x equal to 0, y will become 3, so this is nothing but 0 comma 3. Another line if you want to plot, here also if I put y equal to 0, my x comes out to be 6, so point of intersection is fine, and if I put nothing but y is equal to 0, x equal to 0, the value of y becomes nothing but minus 5, so this point is 0 comma minus 5. Once I have got this, now this is my sample space. This region that they're talking lies in this triangle, let us say ABC. Okay, this is my sample space. So if my total area will be nothing but half of base, that is nothing but 8, into height, that is nothing but 6. This is my total area. Now if I want to write the favorable area, so what they have given is a condition that y needs to be smaller than 1. So let us put y is equal to 1 here. If I put y is equal to 1 here, this point is nothing but 0 comma 1. And if I find this point of intersection, quite simple to find, this is 4 comma 1. So if I want to find, so this is my favorable case. It is easier to find this part, which is not there, in order to find the favorable case. So what I can do is, my probability is nothing but 1 minus when it is not happening. So area of that triangle, half of base, that is nothing but 3 minus 1 2 into height, that is nothing but 4, divided by half of 8 into 6. If I do this, I will get my answer. So if I simplify, you can see this will get cancelled out and the answer comes out to be 5 by 6. That is nothing but option B. Type 4 problem talks about Kolmorov's axiom. Now what does Kolmorov say and how does this start the whole idea of axiomatic probability? So this is the guy who came up with the idea of axiomatic probability. So let us first understand what the idea is and how it is very useful. So he says that instead of writing those favorable cases by total number of cases, let us write probability by using set theory. So sample space S that has elements E1, E2, E3 and E4. So he said that the first thing that you need to understand is if I take any one element, any one of these, the probability needs to lie between 0 and 1. Second is if I add probabilities of all the elements present here, and this is from set theory, you can again see that if I add all of these probabilities, it should add up to 1. Third, what he said that if you want to calculate probability of any event E, and let us say that this event E has two elements E1 and E2, so you can easily calculate this by adding probabilities of event E1 and E2. Now the question arises that, okay sir, I have got the 3 basic axioms, but why do we need them? So we need these axioms in order to calculate probability in those cases when events are unequally likely. What does that mean is basically if I have a biased die, a biased coin. So what is happening is, let us say that we have a die and in that whatever face number would be there, probability will be proportionate to that, x, 2x, 3x, 4x, so on and so forth. So this is the biased die. Or we have a biased coins where head and tail are not coming with equal amount of probability. Then those cases axiomatic probability will become more useful. In other cases also we can use it, there is no problem. So now let us see what kind of problems are based on Kolmorov's axioms. If I look into this 2023 question, it is a very controversial question because the NTA had given the answer of this question as A. This is what NTA gave. And the actual answer of this question is nothing but answer B. I will show you how. And why this contradiction is there, that also will try and explain. So in this question, see what is happening is they are saying that if this omega is a sample space and A is a subset of omega, be an event, then there are two statements that are given. So if probability of A is 0, then A is a null set. So if you think this whole scenario from a discrete set scenario, for example, if I take my sample space as nothing but 1, 2 and 3, and if I say that A is an event out of this, and if I'm saying that, let us say it is something, I don't know what, but if I'm saying that probability of A is equal to 0, so from classical probability point of view, there is no favorable case also here. So if I'm writing this, that would mean favorable cases by total number of cases has become 0. So number of favorable cases is 0. That is what we can think. And hence this option seems to be true. But see, this is only when we have discrete objects. So in this context, this answer seems to be true. And similarly, if this is true, the next one will also be true. But if I take geometrical probability into consideration, and we will see 2-3 questions based on geometrical probability. So what happens in geometrical probabilities, we are taking a continuous space. Let us say that instead of taking this set, I consider a wire. So what we are doing is we are taking a line that starts on the number line from 0 to 1. 0 and 1 are included. So what we are doing is we are taking this line and I am saying that if I want to find a probability of an event A where A is nothing but equal to 1 by 2. So this is a single element on this line. So when we write in terms of geometrical probability, what is the formula? So in this case, probability of any event in 1D, if I'm using 1D, I'm going to use the length, and that is favorable, divide by total length. So this is how I do in case of an non-discrete space. That means continuous space or geometry based problems. So if I take just this one point on this line, the width or the length of this one point. Point is dimensionless, it will become 0. And the total length is 1. So the probability comes out to be 0. The probability is 0, but you can see that the value of A is not 0 or a null set. There is still an element there. So in this case, what is happening is, because of this, we cannot conclude in this manner. So this is fine for discrete space, but for geometrical probability, this statement is false. This is also false. And mathematics says that if you can find one example where the statement is not true, then the statement is considered as false. Hence, the answer to both of these questions should be false. Why the second option is false? Because it is nothing but A bar. So if I'm writing A bar here, if this is 0, obviously it will become 1. So if the first statement is false, second will automatically become false. So it is a very controversial question because the NT had assumed it to be a discrete space, and based on that, whatever they are writing seems to be true. But if you generally see across probability, especially in terms of geometrical probability, the answer is not true. Now this next question is a very interesting question. In this question, what they are saying is, these three E1, E2, E3 are nothing but mutually exclusive events. Exclusive event would mean their intersection is 0. That is one condition. So if I take E1 intersection E2, this is also null set, and like that any two in combination will be same. And then if I take intersection of any three, this will also be a null set, and that is obvious. So now what we are saying is, one very important condition that they have given is they are mutually exclusive events. So what they are saying is, what can be the minimum and maximum value of P1 P, and what they are asking is basically what is the sum of those values. Now let us look into this question. So the first condition will come when the P of E1 will lie between 0 and 1. So if I do this, what am I getting is 2 plus 3P by 6. This lies between 0 and 1. So 2 plus 3P will lie between 0 and 6. 3P will lie between minus 2 and 4. And as a result, P will lie between minus 2 by 3 to 4 by 3. This is first condition. Another condition we can write on the similar lines is, P of E2 also needs to lie between 0 and 1. And if that happens, then 2 minus P by 8 will also lie between 0 and 1. And as a result, 2 minus P will lie between 0 and 8. Minus P will lie between minus 2 and 6, and P will lie between minus 6 and 2. Another condition we have got. In the third part, we can do the same thing for P of E3. So if I take P of E3, that is probability of event 3, it also needs to lie between 0 and 1. So it also becomes 1 minus P by 2 lying between 0 and 1. And if I do so, you can see that 1 minus P lies between 0 and 2. And as a result, what we can see here is minus 1 to 1, and P lies between nothing but minus 1 to 1. Three conditions we have written. Now let us go to the fourth condition. What is the fourth condition? If I take P of E1 union E2 union E3, this also needs to lie between 0 and 1. And this is very simple to find because all the intersections are 0. So this can be written as P of E1 plus P of E2 plus P of E3. This also lies between 0 and 1. So let us write it down, take LCM and do the calculation. And if we write it down, this becomes nothing but 2 plus 3P by 6. The next part is nothing but 2 minus P by 8. The third part is 1 minus P by 2. And if I simplify this, so a good way to do would be to multiply by 2 initially. So this becomes 2 plus 3P by 3 plus 2 minus P by 4 plus 1 minus P is smaller than equal. So I have multiplied by 2, and now we can take LCM as 12. So if I take the LCM as 12, what we are getting is 8 plus 12P. The second element becomes nothing but, again I have to multiply by 3. So 6 minus 3P. And the last one, if I do, to 12 minus 12P. And this is smaller than equal to 2. Again, if I simplify this, it is not a very difficult thing to be done. You can see this 12P and 12P is getting cancelled out. So we have 12 plus 6, that is 18. and 18 plus 8, that is nothing but 26. So this is 26 minus 3p by 12. This lies between nothing but 0 and 2. So this will lie between 26 minus 3p will lie between nothing but 0 and 24. And if I simplify this, if I take, to this becomes minus 26 lies between minus 3p and minus 2, or p lies between nothing but 2 by 3 and 26 by 3. Now all we need to do is basically take intersection of all of these 4 results that we are getting. So let us write all of these 4 results and on a number line and take their intersection. So if I draw a number line, it is like this. The least value, and let us start from the first part. It talks about minus 2 by 3 to 4 by 3. This is the first part. The next one, if I draw on the same number line, it talks about minus 6 to 2. So minus 6 would be somewhere here. 2 would be somewhere here. It is talking about values between minus 6 and 2. If I write the third condition, they are talking values between minus 1 and 1. So minus 1 would be somewhere here, 1 would be somewhere here. So the values between these 2 points. And the last one, if I write, it talks about between 2 by 3. So 2 by 3 would be somewhere here. To nothing but 26 by 3, somewhere here. So if I take all of these values, you can see the common intersection points come out to be between 2 by 3 and 1. Only this much is common in all the 4. So the answer of this question comes out to be your P belongs to 2 by 3 to 1, these values. So the minimum value, that is nothing but P2, comes out to be 2 by 3, and the maximum value, that is nothing but P1, comes out to be 1. So if I add both of these, the answer becomes 5 by 3. That is nothing but option B.
Now let us see this 2023 problem. It is a very interesting problem. It combines the idea of sequence, series, probability, random variable all in one go. Let us see what happens. So in this question, what they're saying is the probability of a random variable x is given by this formula. X can take value 0, 1, 2, 3 till infinity. So if I want to write the total probability, so what I can write from Kolmorov's identity is nothing but if I add all the probabilities, it should be equal to 1. This is the first part, because we are trying to find this value k. Also, what is asked from us is probability of x is greater than equal to 2. So what they're asking, and this will become the second part, is find the probability when x is equal to 2, then 3, then 4, and it goes till infinity. This is what we need to find. For that, we will require this value of k in order to get the calculation right. So let us try and find out k. Once we have got k, I think we will be able to get our answer. So let us find this infinite probability. So if I write here k, if I put x equal to 0, this becomes nothing but 3 raised to the power 0, and this becomes nothing but 1. In the second part, if I put 1, this is going to become k into 2 into 3 raised to the power minus 1. In the next part, if I put k, x is equal to 2, then this becomes 3 into 3 raised to the power minus 2. And this will keep on happening till infinity. So out of this now, if you carefully observe, this is becoming an AGP. Now the sum is equal to 1, we know that. So what we can do is we can take this k common. So this is 1, and this is 2 by 3, this is 3 by 3 square. Then there will be 4 by 3 cube till infinity. This is equal to 1. So we need to find the sum of this infinite AGP. And how to find this sum? Let us take this series separately as S, figure out the value, put it here and get the value. So if I write this as S, this is 1 plus 2 by 3 plus 3 by 3 square plus 4 by 3 cube till infinity. So if I just multiply by R, that is nothing but 1 by 3 in this case. This becomes 1 by 3. This becomes 2 by 3 square. This becomes nothing but 3 by 3 raised to the power 3. 4 by 3 raised to the power 4 till infinity. And the next step is usually to take this and shift it by 1 unit like this and then subtract. You can also subtract without shifting, that is also fine. So on the left hand side, what we get is S into 2 by 3. On the right hand side, it becomes 1.
Then if I subtract, it will become 1 by 3. This will become 1 by 3 square, then 1 by 3 raised to the power 3, 1 by 3 raised to the power 4 till infinity. And the sum of this is quite easy to find, a upon 1 minus r. And you can see that this becomes 1 by 2 by 3 or 3 by 2. Now this is the value of s. So s will become nothing but 3 by 2 into 3 by 2. So what we have got is nothing but 9 by 4. So as we have figured out, if I put this value of s, this becomes k into 9 by 4 equal to 1. So the value of k here comes out to be 4 by 9. We have figured this out. Now let us go to the next part. What does this next part say? Next part says that you find these values. So now you can see that in order to find these values, it will be more easier if out of total I can replace whatever is not there in the series, that is 0 and 1. And this is much simpler. And if I put 0 here, it was nothing but k. And then the next one was nothing but 2k by 3. So if I subtract this, I should get my answer. So this is 1 minus 4 by 9 minus 2 by 3 into 4 by 9. So if I simplify this, let us see what am I getting. So this becomes nothing but 5 by 9 minus 8 by 27. And if I again simplify and take LCM, this will become 27. 3 into 5 is 15 minus 8. So this becomes nothing but 7 by 27. And if you see your option C, it is matching out. So it beautifully combines the idea of AGP with the idea of Kolmorov's identity in order to get to an answer. Now in the second idea, based on conditional probability, what we can understand is if we have an event A and we are talking about the happening of event A when B has already occurred, so this probability can be written as P of A intersection B by P of B. Now this is a very beautiful and important idea because this talks about something that is happening in time and not just in space. So this is how it is fundamentally different from other earlier ideas of probability that we have already seen. So now let us see what kind of problems are based on this idea. Now this very simple question based on the basic theorem was asked in 2019. This question talks about two events A and B such that A is a subset of B. So if I find the value of P of A by A, let us see what we are going to get. So if I apply my formula, it is A intersection B by P of B, and always remember that in axiomatic probability, our psychology would be to apply axioms in order to get the answer rather than using logic. So in this kind of question, once you have applied this, since A is a subset of B, P of A intersection B can be written as nothing but P of A by P of B. Now you know that the value of any probability lies between 0 and 1. And if it is so, what we can say about P of A by B, if P of B takes its maximum value, in that case, P of A by B will be equal to P of A. But if PB takes its minimum value like 0, then in that case, P of A by B will be even greater than that. So what we can write is P of A by B is going to be always greater than equal to P of A. A very simple question based on direct formula application. Now this next question is again based on the direct formula application, but a little bit of more calculation we'll have to do using set theory. Let us see how this just works out. So if I look into this question, what you can observe here is what they're asking is P of A by B complement plus P of B by A complement. Now whatever they say, just apply the formula directly. So if I apply the formula, this is what I'm getting in the numerator, and in the denominator I will get P of B complement. In the next part I will write P of B intersection A complement by P of A complement. Now if I draw a small Venn diagram, it will not be very difficult to understand. So when we have A and B two sets like this from Venn diagram, when we talk about A intersection B complement, we are talking about this region. So for getting this region, what you need to do is out of A, just subtract the probability of A intersection B. P of B complement can be written as 1 minus P of B. Similarly, B intersection A complement can be written as P of B minus P of A intersection B by 1 minus P of A. Now see, P of A, P of B is given. P of A is also given, P of B is also given. No problem. Only thing that we do not know is P of A intersection B, but that is very easy to find because we know P of A union B. So if I apply my formula, P of A union B is nothing but P of A plus P of B minus P of A intersection B. Let us see what comes out. So P of A union B is nothing but 1 by 2. This is nothing but 1 by 3. This is nothing but 1 by 5. Minus P of A intersection B. And if I solve this, P of A intersection B comes out to be 1 by 30. Now let us substitute all the values. So my P of A is nothing but 1 by 3 minus 1 by 30 by 1 minus 1 by 5. And the next part is nothing but P of B, that is 1 by 5 minus 1 by 30 by 1 minus 1 by 3. If I simplify this, this comes out to be 5 by 8. That is nothing but option B. If you look into this next question, in this next question, what they have done is they have given two conditional probabilities. So if I write it down, P of E1 intersection E2 by P of E2 will be nothing but 1 by 2. Also this intersection value is also given. So if I put this value, then from here I can get the value of P of E2. So the value of P of E2 comes out to be nothing but 1 by 4. If I do this steps one more time, with the other part, P of E2 intersection E1 by P of E1 is equal to nothing but 3 by 4. Numerator I can put as 1 by 8 by P of E1 is equal to 3 by 4. And if I find the value of P of E1 from here, it is nothing but 4 by 3 into 1 by 8 comes out to be 1 by 6. We have got both the values. Now after this, what we need to do is, using these values, we need to check the options. So obviously all the options have their RHS as the same. And if you multiply E1 and E2 probabilities, it will come out to be 1 by 4 into 1 by 6 is equal to nothing but 1 by 24. So what we need to check is which of these probabilities given is equal to 1 by 24. So if you check your option C, and you will have to check all the options, but I am starting with the option that I already know is the answer. But if you check this option, what we are getting is nothing but this, and this probability we have earlier also figured out is P of E1 minus P of E1 intersection E2 using Venn diagram. You can make a small Venn diagram and figure this out, not a very difficult task. So this comes out to be nothing but 1 by 6 minus 1 by 8. 1 by 2 I can take common, to 1 by 3 minus 1 by 4 comes out to be nothing but 1 by 2 into 1 by 12, that is nothing but 1 by 24. Again, this 2022 question is a very simple question based on direct formula application. So if we find probability of B by A, it can be written as probability of B intersection A by probability of A. And this is given as 2 by 5. If I put the value of probability of A intersection B, it is 1 by 9 by P of A will be nothing but 2 by 5. So the value of P by A, P of A comes out to be nothing but 5 by 80. If I repeat the whole calculation once more with the other part, so P of A intersection B by P of B will be equal to 1 by 7. Put the value P of A intersection B as 1 by 9 by P of B, it is nothing but 1 by 7. And if I simplify, then the value of PB comes out to be nothing but 7 by 9. Now let us understand what are the two statements. The statement 1 talks about those values from Venn diagram if I draw it. So A complement, that is the region outside A. This region is complement of A. Union B. So this portion will get added. So what you want is this region, or what we can say is basically in complement of A, we just need to add this intersection part. And from here we should get our answer. So it is very simple to do because complement would be nothing but 1 minus 5 by 18. So this becomes nothing but 13 by 18. And intersection was nothing but 1 by 9. So if I do so, it comes out to be nothing but 15 by 18. 15 by 18, if you simplify, it comes out to be 5 by 6, and that is what is given also. So this statement is correct. If I look into the statement 2, Statement 2 talks about a region that is nothing but intersection of both the complements. So if I take intersection of both the complements, this is the region I am getting. So this is nothing but 1 minus P of A union B. And this is easy to find, P of A plus P of B minus P of A intersection B. And if we put all the values into it, the answer of this also comes out to be 1 by 18. So this next option also comes out to be true. So option A becomes correct. That is, both the statements are true. And this very simple question was asked in 2022. It talks about a word problem based on conditional probability. So see, whenever you are doing a question of axiomatic probability, your first idea should be to identify which axiom to apply. So here we can see that the question has told us that it is a question on conditional probability. So they have made it very clear that we need to apply conditional probability axiom. What does that mean is, if I need to apply that, the theorem is very simple. P of A by B is nothing but P of A intersection B by P of B. Or I can also write in terms of n of A intersection B by n of B. This is also fine. So if I need to apply this, I need to have two sets into place, A and B, and that is the reason first step in all axiomatic problem question is nothing but write the set or define the set. So here the set A is when the score 4 has appeared at least once. 4 appears at least once. And my set B is basically the sum on both the dices is a multiple of 4n. That would mean either it can be 4, 8 or 12, since the sum lies between 2 and 12. So once you have done that, the question is very simple. Let us find total number of elements in A intersection B and then divide it by total number of elements in B to get to an answer. So for getting the number of elements in B, what we need to do is check for 4 first. In how many ways can this come? So it can come in 1, 3, 2, 2 and 3, 1. There are 3 ways of doing so. If I want to check for 8, in that scenario, it will start with 2, 6. There will be a 4, 4 in between. And the last would be nothing but 6, 2. So in all, there are 5 ways to do it. And if I check 12, corresponding to this, there is only one way, 6, 6. So what we can observe here is number of elements in A intersection B. That is, B is also happening, but at least one of the elements is 4 will happen in only one way. That is nothing but this value of 4, 4. So this becomes 1. And n of B, if I count all the possible outcomes, it is nothing but 3 plus 5 plus 1, that is nothing but 9. So our probability comes out to be 1 by 9. That is option D. Now again, this 2019 question directly talks about conditional probability. All we need to do is basically first understand the sets and then apply the condition. So what they're saying is probability of event A that all children are girl. When an event B, that is at least 2 girls, has already occurred. So this we have defined. Second, now what we want to find is P of A when B has already occurred can be written in two different ways. P of A intersection B by P of B. A number of elements in A intersection B by n of B. Either of the formulas we can apply. This is simpler in this case, so second formula we are going to apply. Now for doing this, we will have to write down the cases. So if I take family 1, what are the possible cases? Boy 1 and boy 2 are both boys. Boy 1 is there but girl 2 is there. Girl 2 is there but boy 1 is there. And then girl 1, girl 2 is there. In F2 also similar kind of 4 cases are possible. Boy 1, girl 2, girl 1, boy 2 and girl 1, girl 2. So if I understand total number of elements in which B can happen, B means at least you have got 2 girls. So if I take these 2 girls from the first set, then corresponding to this, if I take any one out of the next 2, this, I will have at least 2 girls. So corresponding to girl 1, girl 2, I have got 4 cases. If I take girl 2, boy 1, these two cases corresponding to this, you can only choose one from these three. So corresponding to this also there are three cases, corresponding to this also three cases. And for the first one, we will have only one cases, that is nothing but the fourth case. So the number of elements in B, when at least two girls are there out of these family of two girls and boys or children, the total cases are nothing but 11. 4 plus 3 plus 3 plus 1. Now, if I try and find out the number of cases in A intersection B, that means all the girls are, all the children are girls. That can happen if these two are paired with these two. Hence, answer becomes 1 by 11. That is option D. Again, this 2019 question, we are going to follow the same algorithm. First, we are going to define the sets. So, my set A is, what they're saying is, sum of the selected number is already given as even. So, this will become my B set. Sum is even. And A part says that both the numbers are even. So, both numbers even. Now, what they're saying is, out of 1 to 11, you have to select two numbers in such a manner that it is given that both the sum of both the numbers is even, but both the numbers also need to be even. This is the probability that we need to find. Easy terms, it is written here in terms of set theory. So what we need to find is P of B by A. Again, it will be simpler in this case to apply this formula rather than the other formula. If we apply this formula for this, let us write the possible cases. Now see, in this question, they have not clearly mentioned whether repetition of digit is allowed or not. But let us assume the repetition of digit is not allowed. So if you want to make a 2-digit number, or if I want to select 2-digit, and how many ways can we do it? So if I want to, now this B event is only going to happen when both of them are even or both of them are odd. Otherwise, the sum cannot be even. So both of them are even. This would happen when I fill this first box using 2, 4, 6, 8 and 10. So 5 ways. And this another box using remaining 4. You can see corresponding to this, the answer comes out to be 20. But for the next one, when they are odd, I can fill this using 6 and this using 5. So you can see that the answer corresponding to this comes out to be nothing but 30. The question says that number of elements in B. Now we have figured this out. This is nothing but 20 plus 30 is equal to 50. And number of elements in A intersection B. So the probability comes out to be nothing but probability of A by B is nothing but number of elements in A intersection B by number of elements in B, and this comes out to be 2 by 5. Now if I look into this next problem type, it is based on multiplication theorem. So in this third idea on axiomatic probability is very close to what we learnt in condition probability. If I am writing it like this, P of A by B is nothing but P of A intersection B by P of B. This is known as conditional probability. But if I take this denominator on the left hand side and write it down as P of A intersection B is nothing but P of B into P of A by B, this is known as multiplication theorem. Now we could also have done using P of B by A, and in that case here A will come and here B will come. So A and B can be interchanged also, and if I write the opposite formula. So this is known as multiplication theorem, and once we start applying, we'll understand that how while solving question this becomes very easy rather than just writing it as a formula. Now in this 2023 question, this question says that a biased coin whose probability of it is 1 by 4 is being tossed until a head appears, and the maximum number of tosses are n, and the value of n depends upon this quadratic equation when it has no real roots. So you can see that clearly this question has two parts. The first part talks about the value of n for which this quadratic equation 64x square plus 5nx plus 1 will have no real root. That would mean d is smaller than 0. Get the value of n from here, and that number of tosses needs to be made so that you get a head. There are two parts of this question. So let us try and solve both of these parts. If I look into the first part of the question, it talks about this equation having d smaller than 0. So if I take that, this becomes b square, that is 5n whole square minus 4ac. This needs to be smaller than 0. Now we can factorize this. This becomes 5n minus 2 into 8 and 5n plus 2 into 8. This is smaller than 0. Now see, n is the number of throws, so n is definitely a positive number. So this next term, second term, needs to be positive. So whatever answer we are going to get is going to come from this first part. So you can see that n is smaller than 16 by 5. So the possible values of n that are possible is nothing but 1, 2 and 3. From the first part we have got the values of n. Now let us move towards the second part. So what we can have is basically one throw. So one throw, if it happens, in that one throw head should come, then the problem is solved. If we need to do two throw, the first needs to be tail and then it needs to be head, then the problem is solved. And the third possible scenario is tail, head. For this first scenario, for this to happen, the probability is 1 by 4 because probability of head is 1 by 4. First the tail should happen. So for the tail to happen, the probability is nothing but 3 by 4. For head to happen, it is 1 by 4. And again in the next part, what we are getting is nothing but 3 by 4. When tail happens, again tail happens 3 by 4 and then head happens 1 by 4. If I add this up, what will I get? In this case, what I will get is nothing but 37 by 64. So once you have got this, now comes the last part where we need to get the answer. Now what they're saying is the answer is of the form P by Q. So Q minus P will be nothing but 64 minus 37. And that comes out to be nothing but 27, which is our answer. Now in this question, you might be wondering that where did the multiplication theorem get applied? So if you look into these steps, what I am doing here, I'm not saying it explicitly, but it is getting applied. And then let us understand it using this third case. And most of the times it will be applied in such silent manner. So what we are writing here is, if I write it in terms of multiplication theorem, is first should be tail, then second should be tail, then third should be head. So what I am doing is, I am applying it here by saying that first tail occurs. Then probability of second tail being occurring when first tail is already occurred. And then third head being occurring if first two were tails. So when we are writing it down, it comes out to be this manner, and this is how we will be applying it. But you can see the way we are intuitively applying multiplication theorem to get to an answer. Now in this type 7 problem based on independent events, the basic things that we need to know as a student is the two events are going to be independent when P of A by B will be equal to P of A. So there is no impact of B over A, and that is the reason that the probability of A when B has already happened is equal to P of A. This is the true meaning of independent events. Now let us take two scenarios. One, if two events are independent, what will be the condition? So if there are two events A and B and we are talking about their independency, the idea would be this P of A by B can be written as P of A intersection B by P of B. And now we have said that it is equal to P of A. So the condition of two events being independent is nothing but P of A intersection B is nothing but P of A into P of B. So just by checking this condition, you can tell whether two events are independent or not. Now, there can be another scenario where there are more than two events. Let us say three events, A, B, C. So in these scenarios, what you need to do is, there are two ideas, different ideas that we are going to discuss. One is pairwise independency. So whenever they use this word pairwise, this means we need to check in pair. So A and B is one pair. So corresponding to that, the condition would be A intersection B is nothing but P of A into P of B. And then B and C is another pair. For that, we can again write P of B intersection C is nothing but P of B into P of C. And then there is another pair that is nothing but C and A. And if I take that is nothing but P of A intersection C is nothing but P of A into P of C. Another scenario that might appear, and this is very important, is when we talk about mutually independent. Now this is another word that you need to look out for. Whether the question is talking about pairwise or mutually, this you should pay attention, because all these three conditions, 1, 2 and 3, are still going to be here. So this again we need to check, but along with that we'll have to check one more condition, that is for all the three events A, B, C. So for all the three, this one condition we will again have to check in case of mutual independency. Now this can be increased as number of events increase in the similar manner, but you have got an idea. We need to differentiate between pairwise independency and mutual independency. Now let us see what kind of questions JEE has asked on this area. Now this 2022 is a very simple question. It talks about again the basic application of formula and the independent events result. So let us see how this question works out. So if I draw a Venn diagram, so what they are saying is, in the intersection there is no common intersection to the three sets. So what is happening is something like this, and then the third set is behaving something like this. So it has an intersection with E1, it has an intersection with E2, but not with all the three. So this is E1, this is E2, and this is E3. This is how it is happening in this question. So now what they are saying is, find the value of this part. So we can interpret this using conditional probability. So this becomes nothing but E2 complement intersection E3 complement. We will consider this as one event, and then intersection of E1 with this. This will be in the numerator, and the denominator what we'll get is P of E1. If you carefully look into this set, what are the region that we are talking about? Outside E2 and E3, but inside E1. So fundamentally speaking, what we are talking about is outside E2 and E3 but inside E1. So we are talking about this region that is not in intersection with any of the regions. So if I want to write this, I can write this region as nothing but P of E1 minus P of E1 intersection E2 and minus P of E1 intersection E3. So if I remove these two small regions that are here and here, I will get my P of E1. So that is what I'm writing down. So if I write it down, this is what I will get, and this is nothing but divided by P of E1. And now if I simplify this, what they have given is, these are pairwise independent. That means this part, if I want to write down, can be written as P of E1 into P of E2. And the second part also, again, if I want to write down, since they are independent events, it will become P1 of P of E1 into P of E2. Now with this happens, and if I divide by P of E1, you can see that this P of E1 will get cancelled out, and we are getting a very simplistic relation, 1 minus P of E2 minus P of E3. If I combine the first and the third, it becomes P of not E3 or complement of E3 minus P of E2. And if you look into this, this is being reflected in option D, hence it becomes our answer. Now this very intuitive and simple question was asked in 2020. This question is based on the basic core concept of independent events. So what they are saying is, see, if A and B are independent, this first statement can be written as nothing but P of A. So what this option says is P of A is equal to 1 by 6. Now if you look into the question, what they have given is P of A is equal to 1 by 3, so this option cannot be correct. Now if I look into the second option, this will also become P of A, since A and B are independent. So A and B not happening is also independent. So this will also become P of A. This is given as 1 by 3. Now we can see that this is satisfying, so this becomes a correct option. If you want to check the next one, it will also become P of A, but this is given as 2 by 3, which is not correct based on the question. And if I look into the last one, it will also be P of A, and it is given as nothing but 5 by 6, which is also not true. So your option B becomes correct. Now this next question of JEE talks about a shooter firing n shots in such a manner that the probability of hitting each of the shot is independent of other shots. So whether first will hit or second will hit or third will hit are independent events. None of them depends on each other. The question says that if the probability of one shot getting hit is 1 by 3, then how many shot at least needs to be fired so that the total probability is greater than 5 by 6. So now what can happen is, let us say that the first shot was fired. So it can be a hit or a miss. Then the second is fired. It is a hit or a miss. Like this, n shots were fired. So we are talking about at least one of them should get hit. So you can see that now what can happen is, none of them gets hit is one of the possible scenarios. 1 is hit, 2 is hit, and others are missed. Like this, n hits are possible. So these are the total cases that might be possible. So if I want to find the probability of these cases, it would be much simpler to just subtract the probability of this out of total probability. So total probability is nothing but 1. And if I subtract the probability that none of them is getting hit, so short 1 is also missed, short 2 is also missed, short 3 is also missed. Like this, n shots are all missed. So this is what they are asking us to find, and they are saying that this needs to be greater than 5/6. This is what the statement is. Now if I want to simplify this, since S1, S2, S3, Sn are all independent events, their complements will also be independent. So I can write this as P of S1 not happening into P of S2 not happening till P of Sn not happening is greater than 5/6. Also, this probability is given in the question as nothing but 1 minus 1/3, because not happening. So happening is 1/3. So not happening will become 2/3. So if I put the values, this comes out to 1 minus 2/3 raised to the power n needs to be greater than 5/6. See, now we need to think of a value out of these options which will satisfy this. So if I take or simplify this, this will come out to be 1 minus 5/6 will be greater than 2/3 raised to the power n. Or what we need to find is one such value of n for which 1/6 is greater than 2/3 raised to the power n. Okay. Now all we need to do is basically check the 4 options that are given to us. So if I start with the simplest one, that is 3, and if I put in check, so see 2/3 whole cube. So what we are getting is nothing but 8/27, and we can see that this is not greater, this is not smaller than 1/6. Actually it is greater than 1/6, because this number in the denominator, if you divide by 8, is not coming out to be 6. So this is not a correct answer, so let us neglect this. The next possible option is D. Let us check D now. So 2/3 raised to the power 4, if I try and find, in this case it becomes nothing but 16/81. Now you can see that still the ratio is still greater than 1/6 only. So this is also not the correct option. Next option that I can check is nothing but C option, that is 5. So 2/3 raised to the power 5, if I figure out, it is 32/243, and this comes out to be correct option. So C option is correct. Now in this next question, the problem statement is almost similar like the last question, and then just there is little bit more complexity into it. So what they are saying is they are firing now 3 missiles. Earlier shots were being fired, now missiles are being fired. So what will happen is, now there are 2 stages into it. One, the enemy will try and intercept the missile. So one thing is that it should not get intercepted, and once it is not intercepted, then it should hit the target. This should happen for the first missile. Then they are firing one more, again this should happen, and then they are firing one more, again this should happen. Now see, all of these 3 events are independent in nature. So whatever is happening in first case will again happen in the next case, will again happen in the next case, again happen in the next case. So what we need to do is we just need to figure out the probability of one case and multiply it 3 times to get an answer. So if it is not getting, what they think, probability of it getting intercepted is 1/3. So it not getting intercepted, the probability will be 2/3. And then it hitting the target is nothing but 3/4. So this is nothing but 3/4. So if I want to see what is happening in this case, this could be written as nothing but probability that it is not intercepted, then into probability that it hits the target if not intercepted. So this will be first one of these cases. So this becomes nothing but 2/3 into 3/4, and this is nothing but equal to 1/2. Now this 1/2 will also happen in the second case, this 1/2 will also happen in the third case. And since these are independent event, for all of the 3 to hit the target, the probability would be C, probability of missile 1 hitting the target, intersection missile 2 hitting the target, intersection missile 3 hitting the target, would be nothing but P of missile 1 into P of missile 2 into P of missile 3. And this is nothing but 1/2 into 1/2 into 1/2. That is nothing but 1/8. And if you check the options, A option is getting satisfied. Now this again is a slightly difficult form of the earlier question only. So again, bombing is being done. There is a 50% chance that a bomb will hit the target. What they're saying is, in order to destroy the target, you will require at least 2 independent hits to destroy the target. Okay, so now this is an interesting question. So what is happening is, we need to hit the target at least twice out of n bombs in order to destroy it. So now what can happen is, again, the total probability is, your total cases would be, there are 0 hits, there is 1 hit, then there is 2 hit, and like this there are nothing but n hits. So these are the total cases that are happening. So now what they want this time is basically that the probability of this part needs to be greater than or equal to 99%. This is given in the question. So what you need to do is, in order to do that, let us subtract from 1 the probability of 0 hit and the probability of 1 hit. This needs to be greater than or equal to 0.99. Now what is the probability of 0 hit? So 0 hit will happen when first bomb not landed, second bomb also did not land. Like this, none of the bombs landed. So this can happen since all are independent events into P of B2 bar. Like this we can go till n P of Bn bar. See, now this is given as nothing but, for bombing, if I try find the probability is nothing but given as 1 by 2. So probability that B does not happens is also 1 by 2. So this we can replace by 1 by 2 into 1 by 2, and this becomes 1 by 2 raised to the power n. So we have figured out the first part. Now let us try and figure out the probability of 1 hit. So now what I will do is, out of n, I will choose one of the bombs that will get hit, and this will get hit by probability 1 by 2. Now rest of the things will not hit with probability again 1 by 2 into 1 by 2, 1 by 2. Now this is happening n minus 1 times, since this bomb is already got hit. So the answer to this becomes n into 1 by 2 raised to the power. Now let us try and figure it out further. So if I want to get my solution, this was my first part. In the next part, let us put the value and do the calculation. So this becomes 1 by 2 raised to the power n minus n by 2 raised to the power n, and this needs to be greater than or equal to 0.9. If I simplify this, this can be written as 0.01. If I take 0.9 on this side, is greater than or equal to n plus 1 by 2 raised to the power n. Or this can be written as nothing but 2 raised to the power n by n plus 1 needs to be greater than or equal to 100. Now if you solve this further, I can also divide this by 4. So this becomes 2 raised to the power n minus 2 by n plus 1 needs to be greater than or equal to 25. If you satisfy the values of n, what you will figure out is that n is equal to 11 is the minimum value that will satisfy this. Hence the answer to this question comes out to be 11. Now if I look into this 2023 questions, it is a very simple question. It talks about two dice being thrown independently in such a manner that there is an event A. Now this event A talks about the dice should be in such a manner that the number on the first dice should be less than the number on the second dice. So if I take 1 on the first one, the second can be 2, then 1, 3, like this we can go up till 1, 6. Then if I start with 2, then 2, 3, 2, 4, 2, 5 and 2, 6. And if I start with 3, then 3, 4, 3, 5 and 3, 6, and ultimately 4, 5, 4, 6 and 5, 6. So you can see that there are 5 plus 4 plus 3 plus 2 plus 1, total 15 elements in set A. Another thing, what they're telling us is nothing but there also needs to be an event B. If I take B, what they're saying is B is in such a manner that the die appearing on first die is even and the second one is odd. So if I put even number on the first die like 2, I can write 1, then 2, 3, then 2, 5, and then these are the only possibilities. Second die is odd. Now you can see that in this manner I can write few more elements. Like if I start with 4, 1, then it could be 4, 3 and 4 5, and like this 6 1, 6 3 and 6 5. So you can see that in total there can be nothing but 9 elements here also. Now they are also talking about a third set C. In this event what they are talking about is nothing but element appearing on the first die is odd and second is even. So first will become odd and second will become even. So 1 2, then nothing but 1 4 and 1 6, then nothing but 3 2, 3 4 and 3 6, and then nothing but 5 2, 5 4 and 5 6. This is what needs to be done. Now let us check all the options. First, what they're saying is A and B are mutually exclusive. Mutually exclusive. So now these are the three very important words. Let us first try and distinguish them. So when somebody says two events are exclusive, mutually exclusive, this fundamentally means that number of elements in A intersection B is equal to 0, or more appropriately we should write A intersection B is equal to null set. So automatically this would imply that number of elements in A intersection B will be equal to 0, and that will imply that probability of A intersection B is equal to 0. Wherein there is another term that we use is independent. So what does independent means is, in this case there is no impact on A whether B is happening or not, and this translates into P of A intersection B will be equal to P of A into P of B. Got it? So these are the two things that we need to check. So if we talk about exclusivity of A and B, then A and B should have no element common, but we can clearly see that there are many events, like there are many elements, like 2 comma 3 we can clearly see here is nothing but a common element. So you can definitely say that your first option is not coming out to be true. If I look toward the next option, that is number of favorable cases of the event ABC is 5 6 6, 15 6 6. So this is 15, this is 9, this is 9. So this option also becomes wrong. B and C are independent. Now B and C, if you take, you can see that there is no common element. So here B intersection C is coming out to be null set. So again this option is not correct. But if you check the D option, if I take A union B intersection C, and if I use the property of set theory, distribution of intersection or union, it can be written as A intersection C minus, A intersection B union B intersection C. Now B intersection C is nothing but null set. So this will become null set. So it is nothing but A intersection C. So if I check between A and C, let us see what are the elements that are common. So if I look into this, 1 comma 2, 1 comma 4, 1 comma 6 would be common. And then 3 comma 4 would be common, 3 comma 6 would be common, and then ultimately 5. So there are 6 elements that we can clearly see are common. So this becomes a correct option. Now in this next question, what they are saying is there are 6 balls of different color. And in the first scenario, and this is the scenario 1, in this scenario 1, what they are doing is they are taking 2 balls are drawn succession with replacement. See, whenever while choosing a ball replacement happens, these events will become independent in nature. So what is happening is when you are choosing the first ball, the probability of choosing the second ball is not changing. So now what they're asking is what is the probability that both the balls are of same color, and this probability is given as P. So what will be the value of P? So what you can do is basically you can choose one of the colors, and the probability of that color coming is 1 by 6, and again it is same color coming is 1 by 6. So this is nothing but the probability of first event that is given to us. Now let us take the second scenario. In second scenario, what they are saying is 4 balls are chosen in succession with replacement. Again, when they say with replacement, it is independent event. Probability that exactly 3 balls are of same color. So now what you can do is, for finding this probability Q, what we can do is out of 6 colors we can choose one color. Let us say that the first ball also came out to be same color, second also same, third also same, and now the last ball not coming of the same color would be nothing but 5 by 6. Now see, this is one scenario. Now it could have also happened that this same color ball, so this is the scenario, same and not same happened. So now this can also be further arranged in 4 different ways. So this not same can come at first place, this not same can come at second place, and this not same can come at third place as well. So there are 4 cases of similar type, so we can multiply by 4 and get the answer. So if you divide now P by Q, what they are saying, the answer is nothing but M is to N. And if we do so, let us see what is the value of M and N we are getting. So 6C1 into 1 by 6 square divided by 6C1 into 1 by 6 raised to the power 4 into 5 into 4. So you can see that this 6C1 will get cancelled out. This will also get cancelled out. 6 square will remain. And this will become nothing but this 4, if I cancel it out, this will become nothing but 9. So what we are getting is 9 by 5. So the final question is nothing but what is the value of M plus N. So that comes out to be nothing 9 plus 5. That is nothing but 14. So 14 becomes answer to this question. Now type 8 problem is nothing but total probability theorem. So let us first try to understand this theorem using a very simple example. And then let us jump on to the question that JEE has asked on this idea. So let us say there is a doctor, and this doctor has to reach to a patient to treat him, and he becomes late. Now there are different ways he can become late. One, he takes a taxi, and because of the traffic jam he becomes late. Then what he did was he took his bike or motorcycle and he became late, or he thought that day that I should walk, and hence he reached late. Now the probability of taking a taxi, let us say, is nothing but 1 by 2. Probability of taking bike is nothing but 1 by 4. Probability of walking is again nothing but 1 by 4. So there is no other option. So either he is going to do one of these 3 things. And if he takes taxi, the probability of getting late is again 1 by 2. If he takes bike, again the probability of getting late is nothing but 3 by 4. And if he walks, then the probability of getting late is, let us say, nothing but 1 by 8. So now what we want is basically what is the total probability that he gets late. So now what can happen here is this doctor might have taken this first path. So corresponding to that, the probability that we are getting is nothing but 1 by 2 into 1 by 2. So this becomes nothing but 1 by 4. If we take this next path, this probability comes out to be nothing but 1 by 4 into 3 by 4. And this becomes nothing but 3 by 16. And the third path, if he takes, it will become nothing but 1 by 4 into 1 by 8. So it becomes nothing but 1 by 32. So these are the possible scenarios. So what will be the answer? So if I add all of them, I will get my total probability. And this comes out to be nothing but 1 by 4 plus 3 by 16 plus 1 by 32. Now doing this problem in this way is known as total probability theorem. Now I will write the formula of this whole thing. So what we are saying is, if I theorize it in the form of mathematical statements and set theory, what I can write is basically, let us say that this is the event of getting late. So you can see that your sample space is divided into 3 elements, 3 events. The first event is nothing but when he takes a taxi. The second is nothing but when he takes a bike. And the third is nothing but when he thinks of walking. So there is nothing else that is happening. That is the reason in all Bayes theorem question and total probability question, this probability is always summing up to 1. So this is what this shows us. So now once you observe that, this is one of a good observation that you should have, and this will also tell you whether you are missing on to one of the possible ways of solving a question or not. So this is what has already happened. Now once this has happened, you can see that late can happen if he takes these 3 scenarios. So either if this happens, so if you look into this part of being late, it is nothing but the intersection of taxi and late. Also what can happen is this second part. If you look into the second part, this is nothing but intersection of bike and late. Or what can happen is this third part, and if you look into this third path, it is nothing but probability of walk intersection late. Now if I apply my multiplication theorem here, this can be written as probability of taxi into probability of late when taxi has already occurred. This can also be written as probability of bike into probability of late when bike has already occurred. And the last one, we can write it as nothing but probability of walking and probability of late when he has walked his way. So this is what is happening. So this probability of late can be written as nothing but a summation of all of these events into probability of being late when this event ei has already occurred. I is equal to 1 to n. So this is the general formula. So this is what the mathematical expression is, but most of the time you are going to use this process. So what is this process? In this process, what you are doing in the first step is you are drawing a tree diagram like I drew. And in the step 2, you are writing probabilities across all branches. In third, you are multiplying corresponding to branch. And in the fourth part, you are adding it up. So it is a very simple question. If you do this, you will get your answer. This is the fundamental theory behind total probability theorem. Here also, I will add one more line, also cover up the theory related to Bayes theorem as well. Now, in the case of Bayes theorem, what we are finding is basically probability that he took a bike, and we are already telling that he got late. So you can see that the earlier probability that we are writing here, this has got reversed. So where earlier we were saying that he took a bike and then he got late. Now we have reversed the probability, hence it is also known as reverse probability. Since we are thinking about reasons of him getting late, hence it is also known as causal probability. Now how to find this? In order to find this, what we are going to do is, we are going to again apply condition probability and write this is nothing but bike intersection late divided by probability of late. So if I want to write it down, this will become, the numerator can be written down from again multiplication theorem as probability of bike into late by bike divided by probability of late. Now this is very simple to calculate because this denominator we can get from total probability theorem. This answer we already got. So this I can write it down here as 1 by 4 plus 3 by 16 plus 1 by 32. This we can write it down, and the numerator part is nothing but this middle statement only, whatever we are writing it here. So this becomes 3 by 16. Now if I want to mathematically write it down, how it can be written is nothing but P of any event ei when the total event has already occurred can be written as nothing but P of ei into P of t by ei divided by total probability. This can also be written in one more statement mathematically like this, as summation of P of ei into P of t by ei. See, but most of the times this is very irrelevant to know. What you can do is basically very simply, if you have to find the causal probability of this part, just take this probability and divide by total probability. If you want to find it for this second, let us say for walking, then we will take this part and divide by total probability. And if we want to find it for taxi, what we are going to do is we are going to take this part and divide by total probability. So Bayes theorem is extremely simple. Steps are almost same as total probability theorem, just the formula will change towards that. Now in this next question, first step should be to draw a tree diagram, because in total probability questions and Bayes theorem questions, tree diagram is very essential. Now if I start from here, so if I am tossing a coin, either head will come or a tail will come. That is what the question is saying, and since the coin is unbiased, the probability of both happening is 1 by 2, 1 by 2. Now if the first thing happens, if head is the outcome, then they are rolling a pair of unbiased dice. So if you roll a pair of unbiased dice and note down the sum, we have done this multiple times, the sum can be from 2 and then 3, 4, 5 till 12, when 6 plus 6 will happen. If tail comes, what we are doing is out of this 1, 2, 3, 4 6, 7, 8, 9 numbered cards, they are picking a card. So again, you can see that 1 can come as outcome, 2 and up till 9 can come in outcome. What they're asking is, what is the probability that we get either 7 or 8? So what we are saying is, we can get 7 or 8 from the first case or from the second case. So if I want to write it down, how this will work out in terms of theory, and then I will tell you how it practically works out. So in terms of theory, what we can say is, if head comes, then probability of 7 union 8 when head has already occurred, plus probability that tail comes, and probability of 7 union 8 when tail comes. This is what we are trying to figure out. What does that mean in very simple terms is, now what we want is 7 or 8. So how many ways can it happen? So from the first path, if I take, so 1 by 2 can come, then head has come. Now here 7, if you want to get 7 can come when from the first dice it is 1, second there is 6, and like this we go till 6, 1. So there are 6 cases corresponding to that. So this can come in 6 by 36 cases. And if I am worrying about 8, what will happen in the case of 8? That let us also check that out. So now we'll have to start with 2, 6, and it will go till 6, 2. So you can see that there are 5 cases corresponding to this. So second will happen in 5 by 36 cases. So the first part, that is this part that we are writing it here, this we have calculated, it has come out to be this. That is nothing but, if I simplify, it adds up to nothing but 11 by 72. If I do the second part, I will have to add that up. That second part will happen when this 1 by 2 happens. Now the tail has come, and if 7 and 8 has to come, there are only 2 ways to do out of 9. So answer corresponding to this becomes 1 by 9. Now our final answer will be the total probability or sum of both the cases, to 11 by 72 plus 1 by 9. And if I do so, it comes out to be nothing but 19 by 72, and that is nothing but option C. So it is a very simple question based on total probability theorem. Only thing that you need to do is draw the tree diagram correctly, otherwise you might get it wrong. Now in this 2019 question, the question talks about a scenario wherein in a pot, what we have been given is nothing but 5 red and 2 green balls. Now there are 2 scenarios they are talking about. First is, they pick up a green ball, but if they do, what will happen is, then they will have to put a red ball in the pot. So the composition of the pot changes to 1 red ball has been added, and you can see that 1 green ball got reduced. Another scenario that they are talking about is when they are choosing a red ball. Now in this scenario, what will happen is, your red ball will reduce by 1, and they are going to add 1 more green ball into it. Now what they are asking is, if another ball is chosen randomly, what is the probability this next ball is red? You can see that it is clearly a question of total probability theorem. So what we are going to do in the first step, and we have already done it, we have drawn a tree diagram. Once you have drawn a tree diagram, let us try and solve it. So if you look into the first part, this will happen when you can choose 1 green ball. So this can be done in 2:7 cases. The second case, if you want to choose a red ball, it can be done in 5 by 7 cases. Now if this happens based on the new composition of this pot, now if you want to choose a red ball, the probability is nothing but 6 by 7. And if you do it from the second case, there are 4 red balls, so it is nothing but 4 by 7. So if I want to find the total probability, and if I apply the formula, my answer is going to be nothing but 2 by 7 into 6 by 7, the answer corresponding to first path, and then 5 by 7 into 4 by 7, that is answer corresponding to second path. And if you simplify it, you can see that this is 12 by 49, and the second part is nothing but 20 by 49, and if I add it up, it comes out to be 32 by 49. And if I look at my option, this matches option D. So very straightforward question based on total probability theorem. Now type 9 problem is nothing but Bayes theorem. Let us see what kind of problem JEE has asked on this concept. Now this 2023 question is a direct question based on formula. What they're saying is, there are 3 machines. A, B and C, and all of them manufactures certain percentage of defective bolts. So A will produce 20%, so the probability of this happening is 0.2. The probability of B happening is nothing but 0.3, and probability that a bolt get manufactured by machine C is nothing but 0.5. This is given to us in this statement. What they're saying is A produces nothing but 3%, so that is nothing but 0.03% defective. B produces nothing but 0.04 defective, and C, if your C machine is producing a bolt, the probability of it getting defective is nothing but 0.02. Now what they're saying is the defective bolt has been already found. What is the probability that it came from machine C? So C when D has already occurred. Now, this is what they want us to answer. So now this is the directly formula based question, and more than formula I have shown you how to apply this tree diagram directly. So because we have already made this tree diagram, the probability corresponding to first path would be nothing but 0.2 into 3, so this becomes 0.006. That corresponding to next path would be nothing but 0.012, and that corresponding to next path would be nothing but 0.010. Now if you want to find this probability, it is very simple. What we need to do is, whatever we are getting corresponding to path C, we will take this part, that is 0.010, and we'll divide by the sum of these three. So if I sum it out, it comes out to be nothing but 0.028. So answer comes out to be nothing but 10 by 28, which can be simplified into 5 by 40. And this is nothing but option C. So a directly tree diagram based questions based on direct formula also. Now again a very straightforward question based on Bayes theorem. So what they're saying is, if I try and draw a tree diagram, there are two kinds of people, smokers and non-smokers. 25% of population, or if I take a person, there is 0.25% probability that he is a smoker and 0.75 probability that he is a non-smoker. Then what they're talking about is getting cancer or lung cancer, to be very specific. So probability that the smoker has 27 times more chances. So this will have, if this we can take the probability as P, this will become 27P. Then a non-smoker, then a person is diagnosed with lung cancer. So now what they're asking is, lung cancer has already happened. What is the probability that the person is a smoker? This is what they're asking. So again, we are going to follow the same process as we did earlier. Let us keep this here. And let us follow the process. So let us find each of these branches, what they are going to contribute. See, 0.25, I am writing this as 1 by 4 into 27P. This next branch can be written as 0.75, I am writing as 3 by 4 into P. So my answer is nothing but, I have to take this branch. That is 1 by 4 into 27P and divided by the total. So if I total it up, it is nothing but 27 by 4P plus 3 by 4P. You can see that this P will get cancelled out. And what we have is 27 by 4 divided by 27 by 4 plus 3 by 4. So it is nothing but 27 by 30. And if I divide by 3, it becomes 9 by 10. So what they're asking is, if this is equal to K by 10, what is the value of K? So you can see clearly here that the K will come out to be 9. Now this 2023 question is a very interesting question. What this question says is, you have a bag that contains 6 balls. 2 balls are drawn at random from it. Both are found to be black. So what is the probability that the bag contains at least 6 black balls? Okay, fine. So what can happen is, basically we can have 0 black balls. This is one case. We can have 1 black ball. We can have 2 black ball. 4 black ball, 5 black ball, and then what we can have is 6 black ball. Now, what can happen is if I'm selecting 2 balls out of it, both turn out to be black. So you can see that in this manner, our T diagram is getting developed. First step is obviously to draw the tree diagram. Now what can happen is the probability of this happening is nothing but 1 by 7. This happening is also 1 by 7. And there are total 7 cases, and the same probability of 1 by 7 will come for all of those 7 cases. Got it? Now the probability of this happening for the first case is 0. The probability of this happening for the second case is also 0. For the next case, it is going to become nothing but a 2c2 by 6c2. For the next case, it will become 3c2 by 6c2. So on and so forth till the end. So what they're asking is basically probability that at least 5 black balls. So see, at least 5 black balls would mean these two cases. So this is the question based on Bayes theorem. But they have combined both of these cases probability. So if I write it down, it is nothing but 1 by 7 into, there are 5 black balls, so 5c2 by 6c2 plus 1 by 7 into 6c2 by 6c2 and divide by 1 by 7 into 2c2 by 6c2 plus 1 by 7 into 3c2 by 6c2, and this will go up till nothing but 1 by 7 into 6c2 by 6c2. Once we simplify this, this comes out to be nothing but equal to 5 by 7. So this is the question based on a little bit of modified Bayes theorem, and usually in Bayes theorem we consider one cases, but here they put this at least constant to include two cases. Again, a direct question based on Bayes theorem. So what we need to do is first draw a tree diagram. So what we are talking about is two bag. This is bag A, and then they are talking about another bag that is given as bag B. What bag A has is nothing but 2 white and 1 black ball, and then 3 red ball. Bag B contains nothing but 3 black, 2 red and n white ball. Let us write this as n. So this is what the composition of bags has been given to us. Now what they are asking is, they are talking about an event E when they are choosing a bag and 2 balls are drawn from it at random and found to be 1 red, 1 black. So there is an event E of finding 1 red and 1 black ball. Now what they're asking is basically, let us call this as event E. I'm naming this event as event E. So what they're saying is, what is the probability? Now here comes the question, that event E has already occurred. What is the probability that it happened through bag A? This probability is given as 6 by 11. What we need to find is the value of n out of here. Now it is very simple. If I calculate the probability corresponding to this first branch, so they have not given any kind of a preference of choosing from bag A and B. Both can be chosen randomly. So this can be considered 1 by 2. This can be considered 1 by 2. If I want to choose a red ball and 1 black ball from it, what is the probability? The red ball can be chosen in 3C1 ways, and black ball can be chosen as nothing but one way only. And now for the second one, what we can do is, out of this, 1 red ball can be chosen in 2C1 ways, and 1 black ball can be chosen in 3C1 ways. Divide by nothing but, total balls are nothing but n plus 5, so n plus 5 C2. If I want to calculate the probability of this branch, this is this. The probability of this branch is nothing but this. So our answer would be nothing but 3 into 1 by 6C2 into 1 by 2. Divide by nothing but the total probability, that is nothing but 1 by 2 into 3 into 1 by 6C2 plus 1 by 2 into 2 into 3 by n plus 5 C2. and this is nothing but given as 6 by 11. So if I simplify this, I should get the value of n. Let us try and do that. So in the third step, it is nothing but calculation only. So in the third step, what I can do is, I can take a reciprocal of this. So reciprocal of this 1 by 2 first of all can be cancelled out. And if I take reciprocal of this is nothing but 3 by 6 C2 plus 6 by n plus 5 C2. This divided by 3 by 6 C2 can be written as nothing but 11 by 6. So I have taken reciprocal of the above statement. Now see, 6C2 is very simple to find. 6C2 is nothing but 6 into 5 divided by 2 comes out to be 15. And now this value let us substitute and see what is the value of n that we are getting. So if I do that, this becomes 3, this becomes 15, this becomes 6, this is n plus 5 into n plus 4 divided by 2, and this is 3 by 15 is equal to 11 by 6. If I solve this, the value of n here comes out to be nothing but 4. Hence option C. Now let us say this 2022 question. In this 2022 question, what they are telling us is basically there is a bag 1, and this bag 1 contains 3 red, 4 black, 4 black and 3 white balls. So there are in total 10 balls in this bag. Now what they are doing is, from this they are choosing one ball and transferring to bag 2. Now bag 2 already has, it is given that 2 red, 5 black and 2 white balls. So there are in total 9 balls in this bag. This is already given to us. Now if I take one ball from here and put it here, let us say that that ball is red, then what will happen is the composition of this bag will change, and this bag will now contain 3 red balls. Now if I take a ball that is black from here and put into this bag, again the composition will change. This will be 2 red, 6 black and 2 white. Now if I take a ball from this bag that is white in color and put it in this box, again the composition will change. It will be 2 red, 5 black and 3 white. Now what they're saying is, after doing this job, a ball is drawn from bag 2. The ball drawn is found to be black. So after this, there is one more process further. We are choosing one black ball from here, and from all the 3 bags. So you can see that in the process we have also developed our tree diagram. So if I write all the probabilities corresponding to this, a red ball, the chances of choosing a red ball from this is nothing but 3 by 10. Of that of choosing black ball is nothing but 4 by 10, and white is again 3 by 10. The probability corresponding to this first part would be, now from here if I choose a black ball, it is nothing but 5 by 10. Here it would be 6 by 10, and here it would be nothing but 5 by 10. Now here, that the thing that you need to notice is the probability that we are doing in order to apply Bayes theorem here should add up to 1. It is not essential that in this part it becomes 1. This is not essential, but the first part, it is essential to be 1. Only then you are applying it correctly. Now let us, what they're asking is basically, what is the causal probability that this first branch happens, this branch happens, this causal probability we want to calculate. So now the task is very simple. Let us find all the probabilities corresponding to each of the branches. So this branch would be nothing but 3 by 10 into 5 by 10. For this branch, it would be nothing but 4 by 10 into 6 by 10. And corresponding to this branch, it would be nothing but 3 by 10 into 5 by 10. What we need to do is, in order to find the causal probability that red happens in the first place when the second ball is black, has already occurred. So this can be done in nothing but, we will take this branch's probability, that is 3 by 10 into 5 by 10, and divide this by the total probability. So 3 by 10 into 5 by 10 plus 4 by 10 into 6 by 10 and plus 3 by 10 into 5 by 10. If I simplify this, what am I getting is nothing but 15 divided by 15 plus 24 plus 15. So this comes out to be nothing but 15 by 30 plus 24, 54. If I divide by 3, this becomes 3 in 5 and 3 times 1, 18. So answer becomes 5 by 18, and that is nothing but option B. So a very simple straightforward question based on Bayes theorem. If I look into this 2023 question, there are two parts of the question. One is similar what we have just done, and the second, then when we find this value of lambda, what they are asking is basically length of the side of the equilateral triangle. They have taken this question into coordinate geometry after that part. So they want us to find the length of an equilateral triangle whose vertex is at the vertex of the parabola and is inscribed in the parabola y square is equal to lambda x, and lambda will come from the first part, that is the probability part. So let us solve such kind of questions one by one. So this is a sequential question. The first part will come from Bayes theorem, and once you have applied Bayes theorem, you will have to solve this question of coordinate geometry. So what you need to do is you need to solve this question sequentially one by one. The answer of the first question will become input for the second question. Now let us see how this works out. So let us first solve the first part, that is Bayes theorem part. So what they are saying, there are three urns A, B, C. Let us say this is urn A, this is urn B, and this is urn C. In the urn A, there are 4 red and 6 black balls. In the urn B, there are 5 red and 5 black balls. And in the urn C, there are lambda red and 4 black balls. Now one of this urn is selected at random and a ball is drawn out of it. If the ball is red, the probability that it is drawn from urn C is 0.4. So now clearly it is a question based on Bayes theorem. So what they are doing is they are choosing a urn randomly. So that means this probability becomes 1 by 3, 1 by 3, 1 by 3. And after that they want to choose a red ball out of it. So if I want to do that, corresponding to first part, the probability would be nothing but 4 by 10. Probability for the second one would be 5 by 10. And corresponding to third one would be lambda by lambda plus 4. Now they have given that if corresponding to this path, if I write the probability, it is 1 by 3 into 4 by 10. Corresponding to this path, it is 1 by 3 into 5 by 10. And corresponding to this last path, it is nothing but 1 by 3 into lambda by lambda plus 4. If I want to find the causal probability corresponding to this path, we have done this multiple times now. What I need to do is I need to keep this in the numerator. So 1 by 3 into lambda by lambda plus 4, this will be in the numerator, and the denominator we need to write the total probability. So 1 by 3 into lambda by lambda plus 4 plus 1 by 3 into 4 by 10 plus 1 by 3 into 5 by 10. So this is causal probability of the third path. So this is given as 0.4. So if I solve this out, you can see that this 1 by 3, 1 by 3, 1 by 3, 1 by 3 will get cancelled out. Now let us move to the next part once we have got the value of lambda. So we have understood that this curve is nothing but y square is equal to 6x. And if I draw it to a rough diagram, what I get is nothing but such one such kind of a parabola. And then an equilateral triangle is placed something like this. So see what is happening here is this angle is nothing but 30 degree. This will become L by 2. This side is L. So what I can do is I can find the coordinates of this point, substitute in the equation of parabola and get the value of L. If I do that, the coordinate of this point, so in this triangle that we have been given, this is nothing but L, this is nothing but 30 degree. So this base will come out to be nothing but L cos 30 degree, and L cos 30 degree is nothing but root 3 by 2L. Now you can see that if I want to write the coordinates of this point P that we were earlier talking about, this point P will be nothing but the x coordinate is root 3 by 2L, the y coordinate is L by 2. Put it in the equation of parabola, that is y square is equal to 6x, and get the answer. So if I do so, this becomes L square by 4. This becomes 6 into root 3 by 2 into L, and if I simplify, the value of L comes out to be nothing but 12 root 3, and what they are asking is nothing but the value of L square. So if I do so, the value of L square comes out to be nothing but 432. Now this problem type 10 is the last problem type based on this kind of questions. So if you look into this carefully, it talks about three ideas. One is random variable, second is probability distribution, third is mean and variance. So we are going to see all of these ideas using questions only. So let us look into this first question asked in JEE 2022. So in this question, the question talks about a bag, and in this bag, what you have is nothing but 4 white balls and 6 black balls. We are drawing 3 balls from this bag. Question says that x is the number of white balls among them. So you can see that the value of x here can be nothing but, it can take value 0 also, 1 also, 2 also, and 3 also. So this is what we mean by random variable. So what we have done is we have connected a parameter or a variable with the sample space of the event that is happening. This is a random variable. Now what they are saying is basically sigma square is the variance of the x, then 100 sigma square, what is the value? So now this, after this, it is pure statistics. If you have not gone and watched the statistics video, please go and watch it. In that I talk about how to find variance and mean. The same concepts we are now bringing down into probability. So what we need to do here is, first we need to write this x and make a table. So once we make this table, this is known as probability distribution table. So let us give all the value of x. Now corresponding to this, find the probability of this x. So if there are 0 white ball, how can 3 balls be chosen? Then 3 balls should come out of these black balls only. So out of these 6 black balls, let us take 3 white balls. So it becomes 6c3 by 10c3. So this is the probability of the first event. For the second one, if I want 1 white ball, what I will do is basically, out of 4 I will select 1, out of 6 I will select 2, divide by 10c3. For the next part, out of 4 I will select 2, out of 6 I will select 1 by 10c3. And for the last part, out of 4 I will select 3, and out of 10 I will select 3. So the first part can now be written as nothing but 6 into 5 into 4 divided by 10 into 9 into 8. The second part can be written as 4 into 6 into 2, 6 into 4, 5 divided by 2, and the bottom can be written as again nothing but 10 into 9 into 8 divided by 3 into 2. The next can be calculated as nothing but 4 into 3 divided by 2 into 6 divided by 10 into 9 into 8 divided by 3 into 2. And the last part you can calculate is nothing but 4 into 3 into 2 divided by 3 into 2 divided by 10 into 9 into 8 divided by 3 into 2. Once I've done this calculation, now we need to find two values. One is x into px and then x square into px, these two values. So if I find x into px, this becomes 0. This becomes 1 into 1 by 2, 1 by 2. 2 into 3 by 10 will become 3 by 5. And then 3 into 3 by 10 will become 1 by 10. And then what we want is the value of x square px. So if I do x square, then this also becomes 0. Then 1 square into 1 by 2 again becomes 1 by 2. 2 square into 3 by 5 will become nothing but 12 by 5. And ultimately 9 into 1 by 30 will become nothing but 3 by 10. Now what we need to do is basically we need to add these values. Why? Because this is the formula that we have got for sigma square. Now this is the formula for variance. Now from where does this formula come? And why is this formula? For that we'll have to watch the statistics lecture in detail. So we have two very important formula. This is for variance or sigma square, and there is another formula for mean or expectancy. For mean we have this formula, summation of xpx. So these are the two important formula that we'll be using time and time again. Here they are not talking about mean, so we are not using this formula. We are just going with the first one. So if I do so, it talks about x square px. That means sum of all these elements. So if I do so, what we get is 1 by 2. So if I multiply by 10 and take LCM, so what is going to happen is this is nothing but 20 by 10, and this comes out to be 2. So here you can put 2. And for the second part, what you should observe is the summation is inside the square sign. So we need to add this also, and if I add, this is nothing but 6 by 5. And once you do so, you will have to put this value inside and then square it. This you should take little bit care while doing so. So this becomes 36 by 25. And if you simplify, this is nothing but 14 by 25. Now this is not your answer. What they're asking is what is the value of 100 into sigma square. So if I find 100 into sigma square, that is 100 into 14 by 25. And this comes out to be 14 into 4, that is nothing but 56. So now if I recap, there are 3 or 4 important ideas. The first is random variable. Any variable that is linked to the sample space, that variable is known as random variable. This is the first idea. What we will do is we will use probability distribution table in order to study this. Once we have got that table, using that table, we can find 2 more things. One is the concept of mean or expectancy. This will be represented by mu, and this will be nothing but summation of xpx. So there is a direct formula to calculate it. And there would be a fourth quantity that we need to find, that is variance. This is nothing but sigma square, and this would be nothing but summation of x square px minus summation of x px whole square. So here, since this is also mu, this formula can be rewritten as x square px minus mu square. This is also fine. So these 4 things, if you know, such kind of questions can be easily done. Now this 2019 question, they want us to calculate expectancy, but in a slightly different manner. They have already given us the value of x. The value of x is nothing but 6 is one of the values, 12 is one of the values, and 15. So these are nothing but the money he is winning or losing while playing or throwing 2 fair dices. So this is given to us. Now if he wins rupees 15 for a doublet, so 15 will come corresponding to a doublet. 12 when the throw results into a sum of 9, and he loses 6. This means this is minus 6. When the outcome of throw is anything else, other, I will write. So this is the random variable they have given to us in order to study, and what they want is nothing but mu of this random variable. Let us see how does the probability distribution table looks like. If I write x here, so the values can be minus 6, 12, 15. So now p of x would mean all the outcomes except, now if I write all the possible outcomes here, it will be easy. So if you're throwing 2 coins, I will start with 1, 1, and I will go till nothing but 1, 6. Then 2, 1, 2, 2, 6. This I am writing for my own imagination, and then this will go till 6, 1 to 6, 6. Now this we are writing for our own imagination. Otherwise, you can also use your logic to solve the question. Now see, it is easy to calculate when we are going to get 9. What are those cases? So 9 you can get once you have 3, 6. 9, and we are writing it for 9. So these are the possible scenarios. Then it will become 4, 5. Then it will become 5, 4. And this will become 6, 3. In these 4 cases, this will happen in 4 by 36. This becomes the probability of this event 12. For this 15, doublet needs to come. So doublet can come 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And this will happen in 6 by 36 ways. And apart from these 10 cases, whatever are there, the rest 26 cases, minus 6 he is getting. Now what we need to do is we need to find x px. And if I do so, what I'm getting is minus 6 into 26 by 36. 12 into 4 by 36. And 15 into 6 by 36. What I want is nothing but sum of these quantities, because mu, as we already know, is nothing but summation of x px. So it is a very simple, straightforward question if you get it right, if you understand it correctly. So what happens in the numerator? It is minus 6 into 26 plus 12 into 4 plus 15 into 6. And in denominator, what we have got is nothing but 36. Now this numerator will simplify into minus 18 by 36. So what you are getting is nothing but minus 0.5. So what is happening? The expectancy should be nothing but half, and that too also with a negative sign. So minus half, or half loss of 0.5 rupees. Now one additional thing you should understand here is when we mean expectancy, what is happening is if he's playing this bet, what we should accept at the end of the day? What will be the
total margin or what will be the total loss. So what can be the most expected outcome of that experiment, and that we are trying to study. So you should also understand this meaning of expectancy, because this will also give you an edge while solving questions. Now this 2020 question combines the idea of Kolmorov's identities and probability distribution table. So what we are doing in this question is, what Kolmorov says is basically, if you add all the probabilities, and if you add all the probabilities, it should add up to 1. So if you are adding k square plus k, plus 2k plus k plus 2k plus 5k square, the sum should come out to be 1. And if I do so, what I'm getting is 6k square plus 5k minus 1 is equal to 0. So if I solve from here, I will be able to get a value of k. It comes out to be minus 5 plus minus root of b square minus 4ac by 2a. So what you are getting from here is nothing but minus 5 plus minus 7 by 2 into 6. So if I take my plus sign, because obviously it cannot be negative, if I take my plus sign, this becomes 2 by 2 into 6 comes out to be 1 by 6. So this is the value of k that we are getting. This is the first part of the question. Now the second part of the question, they are asking all such probabilities for which x is greater than 2. So that means probability corresponding to 3, 4 and 5. In the second part, if we calculate x greater than 2, it is nothing but sum of probabilities of 3 plus probability of 4 plus probability of 5. And this again is nothing but k plus 2k plus 5k square. This can in turn be written as nothing but 3k plus 5k square. And if we simplify this by putting 1 by 6, I should get my answer. So this is 1 by 6. This is 5 by 36. And if you take LCM, this will become also 36. This will become 18 plus 5. 18 plus 5 is nothing but 23 by 36. And that is nothing but option A. Now again, similar kind of question was asked in 2022. In this question also, you will have to do it in 2 steps. You will have to find the summation of px and equate it to 1. So if I do so, what I'm getting is 1 minus d by 4 plus 1 plus 2d by 4 plus 1 minus 4d by 4 plus 1 plus 3d by 4 is equal to 1. And if I do so, numerator we can add up. So this is d, this is 2d, it will become 1d. So negative part if you add, it is 5, positive part is also 5, and it is becoming 1. So there is no issue with whatsoever with this part. It is automatically getting satisfied, and from here we'll get no value of d. Only thing is basically we'll have to apply other identities of Kolmorov that says that all of them needs to be between 0 and 1. That is also one of all the probabilities of the outcome. So first condition will come when we write 1 minus d by 4 lies between 0 and 1. And like this, we will have 4 different conditions for 4 different outcomes. So 1 plus 2d by 4 should lie between 0 and 1. And 1 minus 4d by 4, 1 minus 4d by 4 should again be between 0 and 1. And the fourth part would be again nothing but 1 plus 3d by 4 should be between 0 and 1. See, what we need to find is what is the possible values of d, and using that, then the next part is simple. We need to just find mean, and for that we have got a direct formula. So if I do so, this becomes 0, 1 minus d to 4. If I subtract minus 1 minus d, 3, you can see that your d lies between nothing but minus 3 and 1. Now here, from here, if I do 0, 1 plus 2d lies between 4. If I subtract 1, this becomes 2d lies between minus 1 to 3. Or d lies between minus 1 by 2 to 3 by 2. For the last part, next part, it is 0, 1 minus 4d lies between 0 and 4. If I subtract minus 1 minus 4d is smaller than equal to 3. You can see that if I want to find the range of d, it is nothing but minus 3 by 4 to 1 by 4. And for the last part, if I do so, 0, 1 plus 3d lies between 4. 3d lies between minus 1 to 3, or d lies between minus 1 by 3 to 1. Now what I will have to do next is basically I will have to take intersection of all these values. So let us draw all of them on a number line. So if I draw a number line,
And let us see what kind of values they are talking about. The first talks about values between -3, and this is the lowest possible value that we are talking about, and 1, that is also the second highest value. So what they are saying is between these it should lie. This is what we are saying. For the next part, what they're saying is it should lie between not here but -1/2. Somewhere here, -1/2 to 3/2. So 3/2 will be somewhere here. So they are talking about values lying between these two. The next part, if I talk about, what they're saying is it should lie between -3/4, that will be somewhere here, to nothing but 1/4, that is somewhere here. And the last part says that it needs to lie between somewhere between -1/3 to -1/3 would be somewhere here to 1. 1 is already given to us, so this value. If you see the intersection of all of these, what we are getting is only in this region all of them are present, so this can be the possible. So the possible value of D, if I consider all the conditions, should lie between -1/3 to 1/4. Now what they're saying in the question, now let us go back to the minimum value of D. So minimum value of D, when they say that D should come out to be nothing but -1/3. So this is the value that we need to consider. Now we have considered this value. So this probability distribution table will look slightly different. Let us draw that. So if I draw it, this will become 0, 1, 2 and 3. Corresponding to 0, if I put this value, it becomes 1 plus 1/3, 4/3, 4/3/4 is nothing but 1/3. In the second part, if I do 1 minus 2/3, it becomes 1/3, so this becomes 1/12. Next part is 1 plus 4/3, that is nothing but 7/3 or 7/12. And the last part becomes nothing but, if I put -1/3, this becomes nothing but 0. So what I need to find is nothing but x px corresponding to this. So if I multiply, this first part becomes 0, this becomes 1/12, and this becomes 14/12, and this becomes 0. Again, if I add them up, what I'm getting is nothing but 15/12. And 15/12 comes out to be nothing but, if I divide by 3, it becomes 5/4. Now what they're saying is this is not the answer. Take this 5/4 and 60 times this. Multiply by 60. So this becomes 5 into 15. That becomes nothing but 75. So 75 becomes our answer to this question. Now we might observe that there is a transition happening. Earlier questions were direct questions based on mu and sigma, directly apply the formula, get an answer. But slowly we are transitioning towards the kind of questions where it will combine with axiomatic probability and then give us results. Like in this case, they are asking us a conditional probability in order to get to a result. So what we need to do is, let us figure out what they mean. So if I write this as A by B, then from conditional probability, the answer should be P of A intersection B by probability of B. Now, based on the value of A that they have given to us, that they are saying that x lies between 1 and 4. So the possible values of x that can happen is nothing but, and it could take values 2 and 3. These are the possible values that can happen. If I take B, what they're saying is x is smaller than or equal to 2. That means x can take values in this case which are nothing but 0, 1 and 2. So now the question becomes very simple. So if you apply your formula of P of A by B, what we have got in the numerator A intersection B. If I take intersection of both of these, the only intersection point is 2. So here I will have to write the probability of 2. In the denominator, it is probability of B. So here you will have to write P of 0 plus P of 1 plus P of 2. So if you just put it, you should get the answer. So P of 2 in this question is nothing but 4k. P of 0 is nothing but k. P of 1 is nothing but 2k. And P of 2 is nothing but 4k. So if you add it up, in the numerator it is 4k. In the denominator, that is 4 plus 2, 6 plus 1, 7. 7k. K will get cancelled out. Answer becomes 4/7. That is nothing but option A. So it is a very simple question if you understand it correctly. Again, observe that we have been using the ideas of Kolmorov's 3 identities very clearly here in solving such problems. And no need to calculate k here, because k will ultimately get cancelled out. Now let us look into this 2023 question. It talks about a random variable x done in such a manner that two dices A and B are rolled and the number obtained on A and B are respectively alpha and beta. So they want to study the variance of alpha minus beta. X is here nothing but alpha minus beta. So first let us understand what can be the possible values of alpha minus beta. So if I take the minimum value of alpha, it could be 1 and the maximum value of beta, it could be 6. So the minimum value could be minus 5. Then minus 4 is also possible. And the maximum value will happen when it reverses the rule. 6 minus 1. And in this case, it will become nothing but 5. So these are the extreme values of x that are possible. So if I try and make a probability distribution table, because ultimately they want us to find the variance. And from variance, there is again a P and C question aligned after that. So it is probability followed by P and C. That too statistical probability. So first, let us write the value of x here. So x can take value minus 5, then minus 4, then minus 3, then minus 2, then minus 1, 0, 1, 2, 3, 4 and 5. These are the possible values of x that can happen. Now let us write observations corresponding to this. So minus 5 will happen if this becomes 1, 6. Minus 4 will happen if this becomes 1, 5. And then also there is a possibility of 2, 6. 3 will happen if it is 1, 4. 2, 5. 3, 6. 2 becomes a possibility if we have 1, 3, 2, 4, 3, 5 and 4, 6. So one possibility has increased, and minus 1 can happen if there is a difference of 1. So 1, 2, 2, 3, 3, 4, 4, 5 and 6, 5. We can also count it, and here whenever a doublet occurs, so 1, 1, 2, 2, and this will go up till 6, 6. Now we can see that this we do not need to write because these will be happening in the similar manner, just we will be reversing the value of alpha and beta in this case. So corresponding to this, if we want to write the value of px, in the first case it is going to be 1 by 36. In the second case it will be 2 by 36. In the third case it will be nothing but 3 by 36. In the fourth case it will be 4 by 36. In the fifth case 5 by 36. In the sixth case 6 by 36, and same values will again repeat in the opposite order. So this will become 5 by 36, so on and so forth. This is again getting repeated. There's no need to worry about it. Now what they want us is to find the variance. So for that, two values will be required: x into px and x square into px. See, now this first value is irrelevant. Why? Because when I write this, from the first part I will get minus 5 into 1 by 36. But at the same time, in the bottom here, what we are also getting is 5 into 36. So when you will add all of these values, this will come out to be 0. So we do not need to worry about these values, x into px. All we need to worry about is x square into px. So if I write x square into px, let us see what we are getting. So this becomes 25 by 36. The next will become 4 into 4, 16 into 2, 32 by 36. The next becomes nothing but 3, 9 into 3, 27 by 36. The next will become 4 into 4, 16 by 36. The next will become 1 into 5, so 5 by 36. And next will become 0. And then similar kind of values will again repeat. So now if I want to write the value of sigma square, it comes out nothing but summation of x square px. This is the formula, let me write it down. Minus summation of x px whole square. Now see, this term is coming out to be 0, so no need to worry about that. We need to just worry about summation of x square px, and this becomes nothing but, if I start writing value, 25 by 36, then 32 by 36, then 27 by 36, and then 11 by 36, and then 5 by 36 plus 0, and then same values will again repeat. So what is happening is this part will again get repeated, so into 2. So this is what we are getting as sigma square. Now what they are saying is basically the variance of this. The variance is nothing but sigma square. Now let us simplify this. So this becomes a 25 plus 32 plus 27 and plus, this is not 11 but 16, plus 16 plus 5 by 18. This is what we are getting. Now once we have got this value, the next part of the question says that this is nothing but p by q. So our P comes out to be 35. Now here starts the next part of the question, the second part. Now what they're saying is the sum of all the positive divisors of P. So 35's positive divisor we need to write. So for that there is a standard process. We can write its prime factorization. So total number of divisors, we will start writing 5 raised to the power plus 5 raised to the power 1. 7 raised to the power 0 plus 7 raised to the power 1. So this becomes nothing but 6. This becomes nothing but 8. So 6 into 8, 48. A option comes out to be right.
So here what you can observe is what they are doing is earlier the question needs to be direct. Now what they are doing is they are combining it with axiomatic probability. They are combining it with classical probability in order to generate newer and newer questions in statistical probability. And this is a new development that has happened from 22 onwards. Now this type 11 problem is nothing but binomial distribution in Bernoulli's theorem. Now I know that this is out of syllabus, but sometimes the question might come and they will not say that it is Bernoulli's theorem or binomial distribution, but sometimes they might put the question there. If you do not know it, you will have to do a lengthy calculation. So I'm just telling you, in order to avoid that lengthy calculation, that if a Bernoulli's theorem question is there and they ask you to find the value of mean, it is nothing but NP. N is the number of times the trial is being done, and P is nothing but the chances of success. And if I want to find sigma in this case, it is going to be NPQ. So these direct formula based questions can still be there. For simplification of calculation, still you can use binomial distribution. They might not mention it directly, but indirectly such questions has been asked in other topics also, and it can be done in probability also. So it is better to know. We'll take just one example and wind it up. Now in this question, what they have done is they have given a binomial probability distribution. That would mean the mean will be equal to NP and the variance that they have given will be equal to NPQ. So this value is given as nothing but 8. This value is nothing but given as 4. So if I divide, I can get the value of Q, and that comes out to be nothing but 1 by 2. If Q is 1 by 2, we know that P plus Q is equal to 1. So your P will also come as 1 by 2. So we have got the value of P and Q. Only thing that we do not know is the value of N here. Now, if I want to find the value of N, I can put this value of P here. So this becomes N into 1 by 2 is equal to 8. So the value of N also comes out to be 16. So we have figured out all the values. Now, this is the first part of the question. In the second part of the question, what they're saying is, find the value of P smaller than equal to X. Now, smaller than equal to X would mean it can be 0 also, 1 also, 2 also. Till here we need to go. So for this 0, the binomial probability distribution. Now this basic result you should know is, if you are writing X is equal to R, that would mean R success. It is NCR, P raised to the power R, Q raised to the power N minus R. Now this is a basic idea that we need to know. So once we know this, we can apply it here. So this becomes nothing but, N here is nothing but 16C0 into 1 by 2 raised to the power 0 into 1 by 2 raised to the power 16. Next part will become nothing but 16C1, 1 by 2 raised to the power 1, 1 by 2 raised to the power 15. And the last part can become 16C2, 1 by 2 raised to the power 2, 1 by 2 raised to the power 14. So we can see that all of these, if I add it up, 1 by 2 raised to the power 16 will come out. And what we have is 16C0 plus 16C1 plus 16C2. And here also we can use some basic formula in order to get the result very fast. So 1 by 2 raised to the power 16 is fine. This will become 1. This will become 16. And this can become 16 into 15 by 2. And if I simplify this, it becomes nothing but 17 plus 15 into 4 is 60. So this will become 120 by 2 raised to the power 16. And if I further simplify, the answer comes out to be nothing but 137 by 2 raised to the power 16. Now let us check the options. So what they are saying is, what is the value of K here? So K comes out to be nothing but 137. You can see that these basic, now this question can also be done without binomial theorem, but then the calculation will increase. So same question can be asked in the problem type 10 also, but then you will have to do more calculation. That is the only reason I am telling this. It is out of JEE syllabus. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with.
Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.